Welcome everyone to our Aerosol 101 webinar featuring 3 experts in this field. My name is Sarah Cahill. I will be your moderator for tonight. But before we get started, I wanted to hand it over to Julie Lamb, and she's going to say a few words about our organization.
Good evening. My name is Julie Lamb, founder of MaskTogetherAmerica. It's an honor to welcome you to our expert forum, Airborne Aerosols 101. Tonight, we are privileged to have with us Dr. Haddrell, Dr. Angelique Corthals, and Aaron Collins, 3 distinguished experts who will share evidence on the importance of utilizing various tools to end the current pandemic and prevent future ones. Before our host, Sarah Cahill, begins this educational forum, I want to briefly introduce MaskTogetherAmerica to you. Established in 2020, our volunteer organization aims to raise awareness by featuring maskers on social media, sharing annotations of published materials on preventable respiratory infections, and hosting expert forums. I initiated this grassroots campaign at the start of the pandemic after losing friends to COVID. Our advocacy group, supported by a large community, including many disabled and high-risk individuals, is dedicated to educating people about the layered approach to prevent respiratory illnesses. We must avoid contracting COVID. The risks are too great. Speaking as someone who now suffers from autoimmune and sleep disorders triggered by COVID, I can attest that long COVID affects people of all ages. There's no such thing as mild COVID. It can damage organs and lead to chronic illnesses that cannot be cured. COVID and many other respiratory infections require airborne precautions. It's important to understand what makes a disease airborne and how to prevent ourselves, our families, and our communities from airborne outbreaks. This is why our team has organized this forum for you. Without further ado, I will hand over the microphone to our coordinator, Sarah Cahill, who will introduce our speakers.
Thank you, Julie. Thank you for all the work you do for our organization. Thank you for leading us, and we really appreciate having you as our front runner. So tonight, our first guest speaker is going to be Dr. Alan Haddrell. He's going to speak on ambient CO2 concentration correlation with SARS-CoV-2 aerostability and infection risk, a risk analysis discussion. And Dr. Haddrell is an aerosol scientist at the University of Bristol. His research focuses on the complex interactions between aerosol and human health. He has over 50 publications in a broad range of fields, including aerosol science, aerosol generation, drug delivery to the lung, disease transmission, and particulate air pollution. During the COVID-19 pandemic, his team's research into airborne viral decay has shifted the understanding on how and what environmental factors play a role in disease transmission. So thank you so much, Dr. Haddrell, for coming to us live from the UK, where it is the very late evening. We appreciate having you. And you should have screen sharing permissions if you want to pull up your PowerPoint.
Thanks for inviting me. So prior to, as the introduction says, I'm Al Haddrell. I'm a research scientist at the University of Bristol. And spent a lot of years sort of studying like how aerosols interact with humans in a variety of different ways. And during COVID, we really delved into the fundamentals of like how long viruses live in the air, why they lose infectivity in the air. And based on this sort of improved understanding, how we can exploit this and to design better mitigation strategies. So prior to this start here, the questions were sent in to me a few days ago. So I put some slides together to kind of answer the questions and walk through them. I think they're really interesting questions to ask. And there we go. Okay. So you can see my screen all right? Yeah, I'm just going to assume you can. All
Yes,
right.
looks good. Thank you.
Okay. Okay. So, yeah, just sort of like as sort of a starting off point, just sort of maybe coming back to this sort of figure as I'm going through this kind of thing, just sort of discuss what's involved in airborne disease transmission of a virus. And so essentially what you have is kind of, three major parts involved. You basically have virus exhalation. So this is like viral shedding, aerosol production. So like essentially like the amount of infectious virus being produced by a person who's infected. And then you have transport. And so this is things like aerosol dynamics, aerosol motion, viral decay. So this is like how the virus suspends through the air, how it moves through the air, how the virus changes while it's in the air. All of these things matter. And then finally, there's the exposure and infection end of things. So when the person finally inhales it, like what's the inhaled dose? How much of the dose has actually been inhaled? What's the immune response? This kind of thing. And so, as you can tell, these are encompassing really wildly different areas of science. And it's a very complicated process as a whole. And at the end of the day, like all of these things matter, and you really have to try to understand as much of these as you can. And no scientist can really study all of them at all. Like they have to just sort of focus in on some. And so the areas that I've focused in on is I've got publications in peer-reviewed journals in these specific areas. So aerosol production, aerosol dynamics, motion, viral decay is an area where we are particularly prominent in the field right now. In terms of these other areas, like viral shedding, I'm familiar with the field. I work with people in that field. The immunity stuff, infectious dose stuff, the downstream biological end of the behavior of viruses in the body is well beyond my expertise. I get very uncomfortable talking about that pretty quick. So you have questions about that. I suspect there'll be other professionals that can answer the questions much more better than I can. So yeah, so my focus is going to be on the aerosol side of things. So yeah, so a bunch of questions were sent over. So I'm just sort of going to start walking through them one at a time. And so the first questions I got were kind of similar. So it's are aerosols the most common mode of COVID-19 transmission? And is aerosol the same as airborne? And the answer to both these questions is yes. In terms of transmission, there's always the discussion between fomite versus droplet versus airborne. I think it's kind of a silly kind of debate to be had, quite frankly. The difference between like droplet and aerosol, it's just like it's passed through the air between people. Whether the droplets of what size is not particularly important for most people. It's just it's through the air. Recently, this paper coming out on the WHO, where they finally recognized it as being transmitted through the air, and pretty important. So they refer to these as, the exhaled viruses containing droplets are infectious respiratory particles. So that's a new term we all get to learn and incorporate into our nomenclature now, thanks to the WHO. So the next question is, what are the differences between droplet transmission versus aerosol transmission? Now, this photo here is really gets across the idea of like the differences between like droplets and aerosol. And so droplets are generally referred to as the larger particles. And so they have a lot of mass to them. And so when a person sneezes, there's like a velocity to them. The person who really is a pioneer in this field is Lydia Berubia. And so if you ever get a chance to like see one of her presentations or see her talk, she's really an engaging speaker and really has some interesting results and studies she does. But she's the first person I've heard refer to as an aerosol as a ballistic. So I thought that was kind of interesting. So basically these larger droplets are ballistics. They fire essentially kind of like rocks in a way. And so when you talk about like aerosol transmission, you're really talking about, versus droplet, you're really differentiating between essentially like fomite transmission, which is sort of like on the surface kind of thing where these droplets tend to reside to, versus airborne, which is the aerosol particles. And in terms of like how to think about this, it's like the larger particles are really driving short distance transmission potentially. The aerosol is much longer distance transmission. But really, there's lots to sort of consider here. So the larger droplets are much larger. And so because they're so large, they don't spread as far. They settle out of the air fairly quickly. but because they're larger, they carry, much more volume. And so the amount of virus in them is going to be proportional to the volume. So this bar keeps popping up on me here. And so basically, like the viral load is bigger, but they're not suspended in the air, so they settle out faster. And so it's this sort of balance in between small particles with less virus that live in the air longer versus bigger particles with more virus that fall out. And so you're always sort of at this balance between the two. We've done some work looking at basically the aerosol size and numbers that people produce when they talk and sing and just breathing. And what we found essentially is the louder someone's talking, the higher the particle load, the number of potential virus-containing particles or the infectious viral particles are being exhaled. And so this correlates largely with the volume. So, talking loudly or singing loudly at the same volume produce largely the same amount of virus or potential virus-containing aerosol. And really, in terms of like the difference between like droplet versus aerosol, like you don't really get droplet production much from like, someone screaming maybe, but like, in terms of like walking around, breathing, talking, you don't really get droplet production from people. It's largely just aerosol production. So one of the early findings that alarmed people in the pandemic was obviously the asymptomatic transmission. And so what this tells you is, well, if that's a thing that's really important, this airborne aerosol-based transmission is likely going to be very, very important in this process. Oh, my cat in the way there. All right. Next question. How long can SARS-CoV-2 live in the air? So this is very much up my street. So this is data that we collected using some novel technology we developed during the pandemic. And basically, the number you really need to keep in mind is the virus is like 98% inactivated in 40 minutes. So if you'll read in the news or in the literature things like it has a half-life of hours or it can live in the air for 16 hours. These are not what's happening. These are artifacts with the technology that's being used to measure them. I can talk for a long time about that issue. But really to think about it in terms of like amount of virus in the room, if someone's infected in your room and then they leave within 40 minutes, 98% of the virus will be gone or be naturally inactivated. So this speaks nothing to do with like the particles just diffusing out. This is strictly just the virus itself losing infectivity over time. In terms of humidity, what we found is basically the more humid the air is, the more stable the virus is. And so in dry air, it gets inactivated faster. Does the evolution of SARS-CoV-2 change the kind of tools we need to prevent transmission? So this is actually a really interesting question on a bunch of different fronts here. So let's kind of walk through this. And so as the virus has evolved, the infectivity has changed over time. And this has to be true because it becomes more infectious because that's how they evolve, right? That's how they become the new variant of concern because they become the more infectious variants. But really, when we're talking about that, what do we actually mean? And so coming back to this initial drawing I brought up, transmission is this complex process of all these different parameters behaving in unison, right? And so the question then becomes, okay, well, if it becomes more infectious, what's actually changing, right? And so in terms of like aerosol, you're breathing out the aerosol. Well, the droplets are going to be doing what the droplets do. They're going to be flowing around in the air the same way. The amount of aerosol produced, I mean, because again, asymptomatic seems to be important, likely the size distribution and production of aerosols is going to be fairly similar. It might be slightly different, but largely these kind of processes aren't going to be changing, right? So these things aren't leading to changes in the transmission rates. It's these other processes, things like the viral shedding, things like the immunity, like evasion, the viruses pick up, potentially viral decay. And so that's some work we did looking at the different variants up to the Omicron, and we found that basically how stable the virus is in the air is actually doesn't really correlate. It sometimes does and sometimes doesn't correlate with it becoming the dominant variants. And so this is interesting in a lot of different ways because it's like, Well, this tells us that these other processes are more important, right? So like, for example, here we're showing like, a 30% change in viral load after a couple of minutes. Well, if a person's shedding 10 times more virus, then that is going to dominate the space versus the viral decay. And so you have these conflicting processes all going on simultaneously, which again leads to sort of the challenge associated with all this kind of stuff. But really, to answer the question, like in terms of as it's evolved, what tools do we need to prevent it? It's really it's not a matter of kind as much as just sort of like efficiency, right? Like it's becoming more infectious. So, okay, it's dodging the immunity. So you can get boosters, they're designed for the newer variants to try to bump up that immunity response. But in terms of things like, masking, like the aerosol that's carrying the virus is going to be the same sized aerosol that's carrying the virus. And so the mask efficacy is going to be the exact same. The ventilation rates, all these things are going to be behaving largely the same. And so, so it's not a matter of having new tools. It's a matter of just like making sure to incorporate them because you're dealing with something that's more infectious. What CO2 level is the ultimate level for killing Omicron variants? Okay, so this might seem like an insane question to some people unfamiliar with our research, but I can talk about this one all day as well. It's very exciting. So basically, we had a paper come out a couple of months ago in Nature where we explored basically how CO2 itself affects how long SARS-CoV-2 remains infectious in the air. The reason for this is we've been studying, again, like I said at the beginning, like SARS-CoV-2 since 2020, really trying to understand why it loses infectivity. And what we found basically is it has a lot to do with basically when you breathe out, the CO2 in the respiratory aerosol leaves the aerosol. And when it does that, it takes acid with it. And so what's happening basically is the CO2 is changing, the loss of CO2 is changing the pH of the droplet. The droplet becomes very alkaline as a result of this loss of CO2. And it's this change in pH that's really driving the loss. And so what this means is that if the CO2 loss is driving the loss, then if you add CO2 to the room, basic chemistry tells you the less CO2 will leave the droplet, therefore the pH will change less, and this should have an effect. And so, for example, when you talk about, like, again, back to the question, like what level of CO2 matters? Well, this is sort of a model that I've been working on with a group, basically showing how the pH in the respiratory droplet evolves over time. And we see at 500 ppm, the pH goes up fairly high to over 10. Now, if you increase the CO2 level, the pH doesn't go quite as high. So because the pH doesn't go quite as high, the virus dies not quite as fast. And then conversely, if you could hypothetically create a room with 0 ppm CO2, your pH of your aerosol will be upwards of 13.5 or something, some crazy high number. And so what this tells you is that it's not a matter of like there's an optimal level. What this means is that we're on a spectrum, right? And so any change in CO2 is going to have an effect, and it's a matter of just getting it down as low as you can. And so hypothetically, if you get the CO2 level really low, you could really increase the rate of loss. So this obviously has implications in terms of like climate science, in the sense of like the outdoor CO2 level is always going up. And so our utility or ability to access these CO2 regions that really can drive the loss of decay are just not going to be available to us as we sort of move forward. So this is could be very much a problem in the future. But again, so in terms of CO2 levels, just as low as you can get it. It's just that simple. How can ventilation reduce the transmission of pathogens? And so again, back to this drawing from the beginning, ventilation is really important in terms of like, short distance or long distance transmission. And so in terms of the different dynamics at play here, what we're talking about here is ventilation really affects the transport aspect of this process. So it doesn't have much to do with immunity or viral shedding. Those are kind of constants at different ventilation rates. But when you change the ventilation, you start really playing with these different transport dynamics. And so basically by physically, so if you increase ventilation, for example, what you can do is you can essentially remove these infectious particles from the room physically, right? So they just get blown out the room. And so as a result, the dose will just always be diluted. And so that's a physical means by which to that ventilation reduces the risk. And so this is kind of the way people typically think about it in terms of like this idea of dilution, physical removal. But the stuff we've been showing recently, essentially CO2 affects the transmission. And when you open a window, the CO2 level goes down. People with those CO2 monitors can be very much aware of this. And so what you're doing when you open the window and lowering the CO2, you're making the air itself less hospitable for the virus. And so the air begins to inactivate the virus faster. So just shown here on the right is just how the decay is different just by changing the CO2 level from 500 to 3,000 ppm. And what you can see here is there's an order of magnitude more virus after 40 minutes versus at low CO2 levels. And that final 30% of the viral load just kind of stops decaying at high CO2. And so if the concern is, accumulation, right? Because that's when dealing with ventilation, that the CO2 also becomes a major, major concern because eventually you have an infectious viral load that just isn't really going anywhere. And so all of these sort of dynamics, though, like if you have two people, if someone's in the exhalation plume, ventilation is not going to be as useful as, for example, someone who's far, far away. And so ventilation is really important for long distance transmission, less so for short distance transmission. Okay, is fresh air better or air purifiers better in reducing airborne transmission? This is the kind of question I think I could probably might annoy people in these different areas. Well, let's share my opinion on it. My answer is it depends. And the reason for this is sort of as follows. Like if you have a student, say, who's infected in a classroom, and you put a filter in the classroom to try deal with the transmission risk. In order for this filter to actually do anything, the aerosol has to pass through the filter, right? And so as a result, if the students in the area around the infected student are not going to benefit much from this filter. But the students farther away from the infected student will benefit from this filter because the filter is going to stop this accumulation of the infectious viral load from occurring, but there's going to be a regionality to it, right? So again, because you have to physically pass that air through the filter. And as a lot of parents who've built these core side boxes can attest to, when you put them into these schools, you'll show up and then the box will be under a desk or under a table. And so then all of a sudden, these filters won't do much of anything, right? And so when it comes to these filtration units, it's very much not like a passive mitigation technique. It's powerful and useful, but you have to be thinking about what you're doing with it, right? Because it's a tool like anything else, right? And so if used well, it works well, but if not, then it's a paperweight essentially. And so it's just a matter of understanding the processes that are involved with that. And so when you compare the filtration to ventilation, well, ventilation is almost like an averaging effect where it just lowers the average amount of virus in the room at a constant rate. And so if the rate's high, the exchange rate is high enough, then minimal accumulation of the viral load will happen. And obviously, as I mentioned before, reducing the CO2 levels in the room via ventilation increases viral decay. So it's another chemical mechanism by which ventilation is increasing the utility or increasing the rate of loss. In stagnant air, ventilation won't help short distance transmission much. So again, this is speaking to the idea of like you have an infected student here. These students around here are going to be mildly helped out by ventilation, whereas the students farther away will be greatly benefiting from ventilation. But some recent works come out, just some very simple kind of studies, but they're, again, brilliant for that, is if you just chuck in a ceiling fan, you basically uniformly mix up the aerosol in the room very quickly. And so you're basically knocking down this regionality associated with it. And so as a result, rather than having like a pocket with a high concentration of virus and then the rest of the room low, very low, you kind of have the entire room at low concentration. And so this helps, obviously, the people around the student who's infected a lot, but the rest of their risk goes up slightly. But again, relatively speaking, I think more people are better off than not. And so the idea of like, okay, well, just if you open up a window and then that'll increase the ventilation. But again, this is one of those sort of things. The problem with like air is you can't see it. And so what can happen is if you like say open a window on one side of a room and a door on another, you can create like a draft straight across. And you can create things called like eddies, where essentially what will happen is you almost create like a wind pattern, and then you almost create like a swirl in the sense where like the air is like a dead zone, like the air that just kind of sits there. And so this is kind of just like a drawing rendition of this, but there's loads of examples of this where if you have any sort of like false wall or a tall bookcase, you can create these pocket like the famously with the when they put those walls up at the side of tills in the grocery stores, those are kind of dead spaces that are created, right? It's that kind of idea. So even though the ventilation is great, you have a pocket of air that you physically created that's not um, getting rid of that, getting rid of the infected viral load. And so if you're curious about this kind of stuff, I find these CFD models to be just fascinating. And you can look them up. You don't really have to like read them to understand them. You can literally just kind of look at the figures, and they're pretty easy to understand just visually. And if you look at enough of them, you can start to sort of almost like in your mind's eye, see how it works. And then when you walk into a room, you can almost start visualizing in a space how the air is kind of moving in the space that you're occupying. Now, if you want to sort of benchmark how good the ventilation is in your room, there's a couple sort of different ways you can do this. One is the popular one around is obviously these aeronets or just CO2 monitors, right? So if you have a low CO2 in the room, that tells you have a good cumulative low amount of you have cumulative good ventilation in the air. But the problem is that that's also going to be you're sampling the specific region that you're in. And so you're not going to really get a good sense of these like airflows in the space. And so something you can do if you're curious, I mean, if you're curious, if you're in an office space or the library or a school or what have you, and you're curious about like, when I open up that window, is the aerosol actually leaving the room? Is it not leaving the room? Is it setting up spaces where it's going to be like just loading up with virus or the aerosol kind of thing? What you can actually do is, you know, turn off the light, get a flashlight out, and then just spray a bottle and then just watch where the aerosol goes. And if you do this, you can kind of get a sense of like, okay, you know, this is the space I'm in. You don't have to hire an academic to make a 3D model, CFD model of your personal space. You can just kind of do this kind of homemade science to get a rough idea of what's going on. Like when you open the window, are the aerosols moving out efficiently? That kind of thing. And it's this kind of like I don't know, take control of your own environment kind of idea that you have access to just by, you know, simple kind of experiments like this. Okay, next question is being in an empty room, gym, restaurant, almost completely safe. This one, I would argue that, again, because the viral load is 98% gone in 40 minutes. If I were to walk into an empty room, a gym especially with giant ceilings, because when people breathe out, that plume is warm and it's going to tend to go drift upwards naturally. So in high ceiling spaces, that viral load is going to be high anyway. But like if I were to walk into a space and I had a CO2 monitor and no one was in there, I saw no one leaving and the CO2 was low, I would assume that the viral load in there is very, very low. I would assume that's very almost completely safe environment. I understand if you're immunocompromised and don't feel comfortable with that. I mean, you just wait 20 minutes, half hour, then go into the space to ensure that you get this 98% decay before entering the space. But yeah, that's the kind of timescales that I think are relevant for this. These, you know, there's that study that came out in 2020 saying, oh, the virus lives for 16 hours. I assure you that paper, that experiment is terrible, and the virus does not live 16 hours in the air. And I can talk for a while on that. This is the kind of decay dynamics that are occurring. And so, yeah, in terms of if you're worried, these are the kind of the time limits to think about. But again, coupling it with the CO2 measurement is really, really important. Because if the CO2 level is high, that means the virus is not physically being removed because the ventilation is terrible. It also means that viral load is not decaying as well. And so it's really critical that that CO2 level is low when you go into the space. So how long can SARS-CoV-2 live on an N95 mask? So this is sort of a thing a lot of people sort of explore. It's kind of like it's interesting in a lot of different kind of ways, because like basically you have this straight up like how long does it live on the mask, but then you also have like the question of like, okay, once it's on the mask, it's physically binding to the mask, and how well does it come back off, right? So that's what you're trying to sort of get at here. So a paper came out recently, and they showed that yeah, if you put virus on a mask, it can live for weeks, and that's yeah, that's just what it can do. And so the thing to remember is for this experiment, they're putting 10 microliters of sample down. And so 10 microliters is, well, it sounds like a small amount of volume, but in reality, it's actually quite a lot. It's, it's almost like a drool amount of saliva. And so if you think in terms of aerosol volume, aerosols are on something called like pico-liter levels, which is like a millionth, sorry, it's 9 orders of magnitude smaller. So like a fraction of a fraction of a fraction of a fraction smaller is what the aerosol counts are, their size compared to this 10 microliters. So why does this matter? Well, this matters because I think the reason why the question was being asked is essentially, how do you deal with an N95 mask after you've used it? I think it's kind of what the question's trying to get at. And this is sort of how I would think about this. So if I were to walk in a hospital and see an N95 mask on the floor or on the ground, I would assume that the person wore it was infected because, that's what you do. And I would assume because they're wearing it, they're probably breathing into it is one thing, but they're also going to be like drooling into it. And so the amount of viral load in there is going to be at this kind of level that we're seeing here, this crazy high amounts. And so the way I would engage with that is I would say, okay, I'm going to assume that this thing is super contaminated. I'm going to pick it up with a rubber glove or a pen, or if I pick it up with my hand, I'm going to immediately wash my hand or spray it with ethanol. That kind of thing, because that's a biohazard in a sense. But if I was wearing a mask all day, where if I'm breathing in the mask and getting spit in the mask, that doesn't really matter because I'm not going to infect myself. So the only thing I'm concerned about is the viral particles landing on the outside. All of a sudden, we're on the way other order of magnitude scales on the amount of virus that's actually going to be on this mask, right? Because the only virus that's on the mask is the virus that's deposited on it while you're walking around. And so all of a sudden, it becomes much, much like 7 orders of magnitude less risk, right? And so if I were to take it off, I would just, take it off. I'd wash my hands afterward, but I wouldn't be as like, this thing is a biohazard. Because if you think about it in terms of like transmission from that space, you have a mask surface that the only viral load is from deposited aerosol, which is already going to be low. And then you have to think like, okay, then you have the transfer from the mask to your finger, and the finger to your nose or mouth. It's like you have a lot of different things sort of working in your favor to lessen the likelihood of an infection from your mask that you've worn during the day. And so this is sort of how I would think, or how I think about this stuff. But yeah, again, if you're compromised and want to just wash your hands every time, I totally get that as well. There's no sense in yeah. Protect yourself. Okay, next question. Does humidity affect airborne transmission of coronaviruses, including COVID and flu? And the other question is also sort of more to do with like humidity. And so this is one of those questions that's kind of an interesting one, because when you talk about like so when people think about like really anything, it's about how they experience it, right? And so when you think about like disease transmission, how is the environment affected? They always think in terms of humidity and temperature. And the reason for this is that people can feel humidity and temperature. So when I say it's humid in a room, you know what I'm talking about. If I say it's warm in a room, you know what I'm talking about. If I say the CO2 is high in this room, you have no idea what I'm talking about unless you have a CO2 meter, right? But so because of this kind of the way people think about this, this is sort of a thing that people have been talking about in terms of disease transmission for the longest time. And they end up coming up with these kind of graphs where you have transmission risk as a function of humidity. And there's always this U-shaped relationship with viruses. And this is, I mean, they've done animal studies. This is largely true. They've done, yeah, let's stick with the animal studies, but this is largely true. There seems to be, in the mid-range, seems to be the lowest risk of transmission in general. And so the question really is why, right? That's a question. And so when you talk about in terms of, virus exhalation, transport, exposure, again, humidity actually affects a lot of these different processes, right? So like, for example, this is some work we did looking at aerosol dynamics. And so basically in high humidity, right? So this is humidity on the x-axis here. These particles can grow quite a lot. They can take up a lot of water. And so if they take up a lot of water, they're going to settle faster. So based on just simply aerosol dynamics, like how far aerosols can float as a function of humidity, more humid suggests they drop faster. So high humidity should be bad. But then you say, okay, well, let's expand this and say, okay, what about viral decay? Well, viral decay, actually, viral decay at high humidity, the virus remains infectious longer. So these two processes are directly in competition with one another, which is annoying and complicated. And then you add to this like the immune response, where it's like in dry air, your lungs are, the mucus in your lungs is less capable of handling, basically creating the physical barriers to stop infection. And so in dry air, the virus is more infectious, or is likely to be more transmissible based on this property. So you have the virus is higher hanging around the air longer because it's smaller because of this one, but there's less of it around because it dies quicker in dry air. So you have these sort of like all these things competing against each other. And then there's the big one, which I think is really trumps a lot of this, which is basically like behavior, right? So if it's hot and humid, you're going to open the windows to like increase the draft, right? And so you have this aspect as well. And so when you talk about like humidity, the effect, it's kind of like why is really kind of a mess. But I think of the whole, it does seem like, well, if your concern is transmission, just kind of set it to the middle and you're probably okay. As to why that is really, it's, yeah, a lot of people have strong opinions about this stuff. I think, yeah, it's definitely still, the jury's still out on that. So why is COVID and not the flu spraying so well in the summer? Oh, this is a fun one. So every year, influenza just follows this sort of annual cycle, which has been going on for a long time. This is pretty well appreciated. And so I guess the question is like, it's not so much like why is COVID, like, I guess why is COVID different? The question is like, so why is flu seasonal? And so the reason for this is a few different reasons. One, the flu never really goes away, so it's always kind of in the population. And the things that drive the loss of the increase in transmission are things like relative humidity, again, due to mucosal immunity, colder air, viruses seem to live longer in the air. And then again, changes in population behavior. So in the wintertime, people go inside, they close the windows. And then you couple this with the flu being around for a long time. And so there's just a general larger population immunity going on. And so what this suggests is sort of like you get the seasonality because you kind of need all of these things to line up for these other factors to kind of go over that population immunity hump kind of thing. And so that's why you get the seasonality. This is the going theory with this stuff. I'm not a virologist. I think there's a lot of truth to this, but in terms of specifics, I can't really argue one or the other. But the question then becomes, well, why is COVID not? And so in terms of the actual drivers of transmission, they're the exact same, right? But what's really different is COVID's new. And so the population immunity is actually really low. And they also keep creating new mutations constantly, which is a problem. And so basically, as a result, you just keep getting these waves. And really, I mean, I would argue, why is it not seasonal? I mean, there's very little being done to stop transmission as a whole. And so it's kind of ridiculous for people to start asking, like, why is it not behaving itself, kind of thing. I think there's a lot we don't know about it, and there's a lot we're certainly not doing about it. And so the fact that we're getting a wave in July should not be surprising to anybody. Okay, this is a fun question because this is about how I do science. So, does a negative pressure room really prevent the spread of airborne viruses? How does it work? So, if you want to study really dangerous things, you got to use something called a containment level lab 3. And so the way these things work, they're designed to really keep everything inside. And so you have a series of rooms where the pressure keeps going lower and lower as you go deeper and deeper. And so if this is outside, you'll have like a security lock. And then when you go in there, you'll enter something called containment level 1. So in this level here, you can study things like E. coli, like really, barely dangerous kind of things. And then there'll be another lock that you can go through. And when you go through that, there's a pressure change, and it's containment level 2. And so when you open this door, you'll feel the wind being pulled inwards. And then if you want to go to higher study in containment level 2, you can study things like influenza, so things that are infectious but not, too dangerous. If you want to start studying, things like COVID, you have to go into containment level 3. And so what those work is you basically have something called an airlock. So you basically have to like go into, again, another pressure change, close this door. When you're in the airlock, this is where you put on all your gear, your mask and your gloves and your suit. And then you go into the next phase. The next step here is, again, another pressure change. And so this is the containment level 3. And so in each one of these rooms, the way you're getting the pressure change is you basically have a tremendous amount of air being pulled out of these things through HEPA filters and kicked outside. And so if you think about it, if you were to spill something in here, it's going to be pulled out there, but there's no way physically for the air to be pushed this way because it's the pressure is always pulling it inside. And so you have a shower in here. So in case something goes bad in your containment level 3, you can pop in here, have your shower. Here's a picture of Henry Osmond and myself. This was taken when we just started the COVID work. So this is, a couple of days before we started working with the virus. We had some pictures taken. And so basically what we have is we'll have the instrument, the slabs where we levitate the COVID, which is an internal chamber that sits inside a glove box, which is another level of security, which is, sealed off. And that's inside this containment level, which is sealed off by this airlock, which is sealed off by this containment level 2. So you have all this series of physical barriers. So if you were to get a virus out of this room somehow, it's at the point where it'd have to be deliberate. Like there's so many safety protocols in place. So it's really good at preventing the transmission. So probably one of the safest places to be is these high containment labs. Okay, so what is the optimal environment to minimize the risk of airborne transmission? It kind of bums me out, but like I think people kind of forgot about the Swiss cheese. It really is just all hands on deck. Wear a mask, ventilation, filtration, UV, we have so many tools. No time in history have we understood airborne viruses more than today, and yet it's not being used. I don't know why. But yeah, it's all of it. Like get the CO2 level down. All of these things really add up, and get your boosters. All of it. I think this is the last question. How does a public health organization decide whether a virus is spraying through fomite, transport, or airborne transmission? The answer is poorly. It took 2 years, obviously, famously, for the WHO to say it was airborne. This is actually kind of one of those funny questions where you'll go to a meeting with a bunch of people in the field and ask, basically, how do we decide if it's airborne or not? And you'll get 10 different people, world leaders in their area, giving 10 very confident answers that are all different. It's very, very interesting because it's really complicated. It's not like, because there's so much involved to be a successful airborne transmission. And the question is like, what check boxes have to be clicked for it to actually be airborne transmission? And it's not like if I gave someone a novel virus and said, okay, what properties does it have to determine if it's airborne? You don't really know until it's like in the population, really. It's a real it's a real problem. And again, the evidence of that is the 2 years has said that's airborne. Yeah. And so, oh, there we go. I guess that's the end of it. So with that, any sort of questions?
Yes, we actually did have some questions in the chat for you. People have been having a bit of a discussion here while you were having your presentation, but
all good, I hope.
Yes, all good. Sunshine was talking about your comment about the 40-minute decay and wondering if you could talk a little bit more about the infection risk after the 40 minutes. So in the previous studies where COVID allegedly stayed in the air for 16 hours without increasing ventilation, is that not correct in a real life setting?
So the way that 16-hour measurement was made using a rotating drum where they don't understand the conditions in the drum. And so basically what they've done is they've created an artificial system and just kind of forced it. And like the data is non-reproducible. It's just terrible. It's one of those things where it's like, it's a pandemic and I want to be in the news. Here's my experiment to prove something, kind of thing. And that paper really upset me quite a lot because it's not helpful because it terrified a lot of people. And it's absurd. If you look at the data, it's absurd. It's an absurd paper. Yeah. And so in terms of the half-life of an hour, I can show you I'll show you sort of what's going on in terms of the technicalities of it all. But I can share my slide again. When people talk about like the half-life of being like on an hour kind of thing, what they're actually measuring in that case is kind of the decay rate in this section here. These other technologies can't measure this large 90% of the decay. They're just kind of measuring the last sort of 10%. And so that last bit does decay slower. But again, 98, 99% of the viral load is gone at that point. And so in terms of the amount of virus people exhale, we're not exhaling trillions of viral particles per minute. We're exhaling like hundreds or thousands kind of thing. So the viral load cumulatively in the room is never crazy high unless we change the conditions like CO2 to stop them from decaying and then physically stopping them from moving ventilation. And then they start to really begin to accumulate. And that's the thing. It's understanding like how we are making things bad and then sort of stop doing those things kind of thing. But yeah, so in terms of the overall decay rate, this is the decay rate. In terms of transmission risk after that, that's something I have to probably take up with the modelers kind of thing. But it's one of those like 99%'s gone. You have diffusion carrying a lot of it away. You have ventilation carrying it away. It's just a numbers game. What the percents are, I don't know. I don't know how anyone could put sort of hard values to those, but they're just yeah, estimates at that point. But it's just very, very low.
Thank you.
Yeah.
Roan would like to know, in ASHRAE 241 standard, it assumes 1 CFM of ventilation is equivalent to 1 CFM of filtration. Your team's recent work shows that the CO2 level affects the decay rate of SARS-CoV-2 in aerosols. Does this mean that ASHRAE 241 should be updated to take into account CO2 level?
I think so. I think a lot of these sort of systems they incorporate these sort of slower decay rates as well. But yeah, that's again, my opinion is going to be biased on this, but I think it should be because it's clearly the largest thing that affects decay by far is the CO2. But like that's not for me to decide. You know what I mean? That's my job is to understand these aerosol dynamics, understand these processes, feed it to people, and then they kind of make those decisions. I try not to get too involved in that. I have my opinion, but I suspect other people think I'm probably wrong on that, which is fair because I don't swim in those waters.
Our advisor, Dr. Robbie, wanted to ask you about HEPA filtration. So she's a doctor, she works in clinical settings. If she's in a session with someone, would it be better to put the HEPA filter between her and a patient, or should it be closer to the patient if the patient potentially is contagious?
Yeah, I would have it in between you. And I actually do the what's it called? The spray bottle thing and just see if like opening the window kind of creates a draft of a certain direction. But yeah, it's a physical means, right? Because like you see that decay rate, like the initial few minutes is really important, right? And so if you have the filtration in the middle, if anything doesn't go through the filtration, it's going to be floating around the room, getting diluted a lot and decaying a lot. So by the time it reaches around to you, potentially it's not too low of a dose, or it's just not even there. But yeah, I would definitely just rate in between. Or yeah, I mean, I don't. This is one of those things you have to do the CFDs to see like where exactly it could be. But as far as I'm concerned, as long as it's in between the two of you, that's the main thing. Because you're
All
forcing
right.
the issue. Yeah.
Thank you. Our final question, and then I'll let you wrap up here. How do we prevent infection by COVID and CO2 traveling through vents into our bedroom and bathroom? This is a problem in homes where other family members don't take COVID precautions and in apartment buildings that have a shared HVAC system.
Oof. Yeah, that's the tough one. Yeah, because there's all those studies early on about like, yeah, poor, I think it was the bathrooms in Korea or something like that was working its way up. Yeah, yeah, it would just be like the just filtration. Yeah, I don't know. I think it's just a matter of just filtration, ventilation, if you can. I mean, the advantage that we have in the West in a lot of ways is the fact that we can open a window and that actually helps things. There's a lot of part of the world they open a window and it doesn't help things. And so, yeah, I would just encourage that. Just keep an eye on the CO2 monitor, right? If the CO2 is going up, but your window's open, that tells you something's wrong, right? Yeah. Wish I could give you a better answer than that, but these are kind of tough questions. They're kind of like specific to the area. That's why I'm trying to give answers or to the other ones in terms of like, here are some tools, like these are the processes you should be thinking about. These are the tools and the toolkits you can have to try to address the specific environment that you're in. Because everyone's are different. That's the problem. And so it's also you can be part of the solution to that problem because you're there and you're the one thinking about this more. If you're coming to this meeting now, you're obviously very engaged with this process. And so you have the wherewithal to do something about it.
Thank you so much, Dr. Haddrell. We really appreciate you being here, especially knowing it's so late. I know there were a few more questions in the chat. If you feel like hanging on after your session and talking to people who might have follow-up questions in the chat, you're welcome to. Otherwise, if you need to get going, we also completely understand that. And folks, we're going to take a 5-minute break. Our next session is going to be with Dr. Angelique Corthals, and we will see you here in 5.
Yeah, the best advice for layers of protection when you're a sole person in a group. Things I do, which again, whether it works or not, wear masks, and I'm a big proponent of like social distancing. I think it's important. I think avoiding crowds. When you're talking to people, don't stand right in front of them. Because when you're talking, you produce orders of magnitude more aerosol than when you're just breathing. So if you sort of stand to the side, sort of envision that plume. It's sort of things like that that I think help. Don't stick around in indoor spaces long, especially if there's a lot of people there. Yeah, those are kind of the thought processes that go through my head when thinking about this stuff.
All right, welcome back, everyone. Thank you for being here tonight. Our next session is going to be with Dr. Angelique Corthals. We are going to talk about how to protect each other from common airborne diseases, a pandemic risk discussion. So Dr. Angelique Corthals is an associate professor for pathology, biomedicine, and epidemiology and biological and forensic anthropology at the City University of New York, John Jay College of Criminal Justice. Dr. Corthals studies the link between neurodegeneration and pathogens and metabolism, as well as the histomorphology of trauma at CUNY. She also works with MSF, Doctors Without Borders, as a consultant on diagnosis, treatment, and vaccine healthcare and medicine for all. She received 2 National Science Foundation grants to study COVID-19. We are grateful to have an educator specializing in governmental pandemic preparedness as our advisor. So, Dr. Corthals, thank you for being here with us once again.
Thank you so much for having me again. Hello, everybody. I'm very happy to be here. I don't have a presentation like Dr. Haddrell. I guess I didn't understand the assignment. No, I'm kidding. It's just because the questions that were asked, were very fairly obvious without the need of a support. Unlike Dr. Haddrell, who really needed support for like visual support for his presentation. So I'm just gonna go straight up to the questions that were asked. So first of all, yeah.
Is it okay if I feed you the questions so that Julie can make some video content out of them?
Oh yeah, absolutely. Yeah, go ahead.
Perfect. Okay, thank you so much.
Yes.
So Dr. Corthals,
Better have
what
to
are the most okay, no worries, sorry.
I'm kidding you. Go ahead.
What are the most common airborne pathogens?
Right. So the flu is of course the one that we always think of, the common cold, which ironically 3 common colds are actually also coronaviruses. And then of course SARS-CoV-2, SARS-CoV-1, SARS-CoV-2, MERS have reared their ugly heads out there, but the flu is by far the most common, and the other most common in a non-virus category is tuberculosis. Although this is a bacterium and it has a really complicated life cycle that I'm not going to go into right now, but it is one of those that is the most common pathogen that are airborne.
So I think Dr. Haddrell spoke about this a little bit, but we had a question from our audience about why COVID and not the flu spreading year round.
Yes. So, well, actually, there's many different components there. It's a very complicated situations with this, but the simple answer is, first of all, evolution plasticity. Unlike the flu, which tends to be seasonal, SARS-CoV-2 has a much higher evolutionary plasticity, meaning that it evolved variants much faster. So that's one of the reasons, and it usually has the variants have a life cycle that sort of are working in combination. So we're seeing what we call a variant soup right now, and so you can literally be infected with one variant of COVID, and then fairly shortly after being infected by another variant. So we're, the other thing with SARS-CoV-2, unlike the flu, SARS-CoV-2 has a much, hope you're not hearing that. Are you hearing the noise behind me?
Not very much.
Okay. That's, of course, the parrot has decided to play while I'm talking. Been sleeping the entire other time, In any case, so the other thing about the seasonality of the flu is it basically has a life cycles where it starts in the southern hemisphere and comes up to the northern hemisphere. It starts in the winter in the southern hemisphere and comes to the winter in the northern hemisphere. And it has to be, the virus is much more susceptible to weather patterns and to our behavior during the change of weather patterns as well. Sorry about that.
Thank you.
Sure.
Does a surge in COVID make it harder to detect if H5N1 is infecting humans?
No, it shouldn't. Sorry, let me put it that way. It really shouldn't. If we were prepared and better prepared, or if we had the assurance that our public health administrations were better prepared for it, it wouldn't make a difference whatsoever. We can monitor wastewater just the same. We can monitor spreads among cattle farms, poultry farms. We are monitoring wildlife. I know that there are monitoring going on of wildlife bird populations. The problem is that what we need is a concerted effort, sort of a centralized effort where all of these data go into a body that is concerned with human public health, and that will catch essentially the first occurrence of transmission from human to human, which is of course the big moment for a virus. That's when it transmits from person to person, then you have a much bigger problem on your hands. And it's not far from that, because of course it's been spreading in mammals, it's spreading into our domesticated mammals, and that makes it that much more dangerous.
Why did the World Health Organization say COVID spreads through contact and droplets, and recently announced that the virus spreads mostly through airborne transmission?
Well, having worked at the WHO briefly, everything at the WHO takes an enormous amount of time, and declaring a pathogen to be whatever, to be more virulent, to have airborne transmission, to be blah, 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 requires an enormous amount of time. They don't want to repeat a mistake that they made during, I don't know if you remember, during the swine flu, where they sort of kind of botched the entire response to the swine flu in the opposite direction by being too cautious, but they botched it in terms of the communication to the public. They thought it was going to be much worse than it became. And in fact, it wasn't bad because they took so many precautions ahead of time, right? But again, this is a human problem, and this is an administrative problems, and it is more than it is the biology of the virus itself. Of course, when you have a novel pathogen, it's very difficult to know immediately how the pathogen behaves. So you have to have a consensus of scientists, which means that you have to have experiments to actually show that a novel pathogen has a specific type of transmission. They were going for the transmission that we know mostly of airborne viruses like the flu. And the fact that it's called airborne now doesn't particularly precludes the fact that the droplets are completely out, in terms of, like, if you spit in somebody's face, you can still have viral particles inside of that spit, right? So it's not, it's not one or nothing, you have to be, they just upgraded it to the, what is it, infectious something particle now, infectious respiratory particle. I hate it when they invent new acronyms for us to remember. I hate them so much.
It should be so easy to just say airborne, right?
Yeah, I know, right? But no, because that would be admitting a mistake.
The US government claims bird flu spread to humans via swallowing contaminated food and inhaling contaminated droplets and dust. What does a government agent need to do in order to confirm the pathway of transmission? How do they know it isn't airborne?
What I said before, it has to be experimented, and also the cases that are arising in the population of farm workers have to be thoroughly investigated to find out what they were doing at the time, whether they were touching specific products or whether they were rubbing their eyes. And of course, it's very difficult because whether you know it or not, you're touching your face all the time. So that's another thing. That's you can't always rely on witness testimony, but they just have to investigate thoroughly and then experiment based on those investigations. But I'm always wary of reports. So one thing that I want everybody to understand is there is a huge difference between finding a live virus on a surface or in dust or through the air versus finding viral particles. Because, and saying a live virus in and of itself is kind of not the right nomenclature, but finding a virus that can be infectious. Because with PCR, for example, you can detect a tiny little bit of that virus, and all of a sudden you have, you make a piece, you do a PCR test on a piece of dry dung or a dry cow pad, and all of a sudden you have this huge quote unquote viral load, but it's actually based on a tiny little bit of the virus, and it doesn't really tell you whether those particles are actually virulent. So you have to be very careful when you read literature about the amount of virus somewhere, that you're reading exactly what the methods for calculating the amount of viruses has been, because you want to make sure that they calculated the amount of viruses that can be infectious versus just viral particles that are found out there by the virtue of PCR being so sensitive.
Can H5N1 become an airborne pandemic spreading from human to human?
Oh, it definitely has that potential. Yes. I mean, I've been looking at H5N1 for the past, actually even before the SARS-CoV-2 pandemic started in 2020. And my first huge worry was when the virus was found and was mass killing sea mammals. Because this is a scenario that unfortunately we've seen before. And ironically, the scenario that we've seen before of an airborne pathogen transmitting from birds to sea mammal has been tuberculosis in the Americas. So the old history was that tuberculosis was brought to the Americas by the Europeans, and of course now we know through archaeology and bioarchaeology that that's not the case. There were cases of tuberculosis well before any kind of contact with the Europeans, and those came from actually an infection from first a reservoir of tuberculosis in sea mammals, which then got to domestic animals, and then got to humans from their domestic animals. So it would be a situation that we've met before. The potential for H5N1 to become to be transmitted from human to human is huge. Yeah.
The CDC says so far that it doesn't see signs of human to human spread. What will make them declare that there are cases of human to human transmission?
When there's a human to human transmission, I mean, when they actually get a case where there has been no contact with potential infected animals, and the transmission came from somebody who transmitted the virus to that other person, which is not that easy, because if you live, so generally speaking, the people that will be infected by another human that has been infected by an animal that they were handling, it is usually the person in the household. And so there's a variety of things that in the environment of that household that can produce a false positive of human to human transmission, such as, the person came back and didn't wash their hands properly, and it was transmitted through fomites, or the clothes were infected and the person handled the clothes, but they were not so it really is a sleuth work to find out where the person was infected and how they were infected. Unfortunately, it doesn't work quite as rapidly as we see in the movie Contagion, but that's the idea. You really have to do a sort of a detective work on making sure that the transmission is truly from human to human rather than a potential accidental contagion from another source.
So the CDC says you can be infected with bird flu by inhaling contaminated droplets. Does that have the potential to become airborne?
Yeah, very much so. Yeah. Again, that doesn't preclude, so that actually takes me to the next question that I'm seeing here, and I'm just going to ask that question because I can answer both at the same time. So this the other question is, can the form of transmission evolve as the virus mutates? Technically, I would say no, but yes, meaning that what happens is the virus can mutate ever more efficient methods of transmitting itself, which means that it becomes more transmittable through aerosols, right, and through droplets, through fomites, but it will most often just stay within its category. So you have viruses like monkeypox, for example, which requires bodily fluids, right? And it tends to stay there. That tends to, it's not aerosolized. Viruses that are more in the category of airborne viruses will tend to move into that airborne category at some point when they evolve the capacity to become more infectious and to have found that kink in our armor to just get in.
What is the current CDC standard for airborne precautions?
Surprisingly high. So actually they do have, let me see if I can share this. This is right here. This is the droplet precaution, and this is the airborne precaution, which is actually saying, hey, you got to put an N95. With the droplet, they're basically saying cover your eyes, which is never a bad thing. And you see that the mask here is not as great as we'd like it to be, right? But so for airborne precaution itself, this is what we've understood as being a high precaution. The only thing is that you have to dig for that. So if you look at this, there's a dissociation between their message on airborne precautions and COVID. And that's something that has nothing to do with the biology or the engineering or anything. That is something that has to do with politics more than anything else, and administrative burdens too.
What steps do our public health agencies need to take in order to prepare America for a new airborne pandemic?
Well, first, it would be great to have a public health body that is not under the thumb of politics, but we can only dream. And more importantly, and I think that's been the massive failure of the pandemic, at no other time in the history of the world has more scientists been working to find a resolution to a novel pathogen, to the menace of a novel pathogen. So I can't say like add more scientists because there couldn't be any more scientists to be added. But the biggest problem has been communication, and it stays communication. And the communication has been very poor. It was great in the beginning, and then as soon as COVID became inconvenient, it dropped dramatically, and it went in favor of a political response that was completely dissociated from the biological reality of the pandemic. And this is where we live right now. So what we have to do is to not put our head in the sand and have a government that understands that virus doesn't care about your feeling or your economy. It only cares about doing its thing. And its thing is to get into a virus-making factory, which are us, and infect and kill and move on to the next virus-making factory. And until we don't have a government that respects this and respect the fact that we have vulnerable population who will always be vulnerable no matter what, and respect that they have a right to live, we are not going to have an efficient response to a pandemic.
Is H5N1 treatable?
It is. Well, it is the way the flu is treatable. So we do have some antivirals like Tamiflu, for example. So it's the same antiviral that we're using for the flu are being used for H5N1. They're not great, but there's new antivirals that are specifically targeting H5N1 that are in the making right now. As I understand, Pfizer, for example, is looking into that. And we also do have few vaccines that already exist for H5N1 in humans. We also have, of course, vaccines that have existed for a long time for poultry and cattle and, for non-human animals.
Is the world at large prepared for another airborne pandemic?
We're not all equal. I think that some societies are better prepared than other societies that have accepted that mitigations and respect for one another is important, are going to fare better than those who decided that living the lie of disregarding a clear and present danger is more important to them because it makes them feel better.
Apart from the important challenges of protecting farm workers, what should Americans in general be doing to avoid the risk of H5N1 infection?
The biggest thing we can do right now is to be eagle-eyed on the potential of H5N1 becoming transmittable from human to human, and that includes testing and monitoring wastewater levels as well, but testing every single farms, and also make sure that all farm animals are vaccinated, that you have herd vaccinations, so that you also don't have to cull all of those poor animals just because there is an outbreak of the virus. And of course, the other thing, which is a lot more complex, but I've just reviewed some grants on the subject. Of course, monitoring wildlife populations, especially fowl populations, is hugely important.
Someone outside my window sneezed right when you said that, and it felt foreboding.
And damn,
close the window. What should state and federal governments be doing to contain H5N1?
Well, as I said, same thing, right? Vaccination of herds, making sure that farm workers are well protected. The problem in this country is, of course, the population of farm workers who are immigrants, and there's a problem in that respect in two different ways. So some farms try to hide their immigrant workers because they don't have a legal status. And these workers will also not seek healthcare when they are sick. So this is a huge potential right there for undercounting cases and missing cases of human-to-human transmission. So if we could legalize farm workers, wouldn't that be wonderful? There's plenty of space here. I mean, come on. There's nobody in Wyoming. Literally.
Some US politicians have proposed banning masks. How will that affect infection control of airborne diseases?
Okay. Okay. So this is the stupidest piece of legislation ever. When we need so many more pieces of legislation, they're wasting our tax money on this ridiculous thing. The arguments that I've heard over and over from politicians has been, well, we're doing this because these laws were on the books before the pandemics and we suspend them for the pandemics. And then of course the name that you hear is Ku Klux Klan. And it's like, okay, first of all, not the same mask at all. So that's a full mask, right? So, and the problem with these mask ban is that, first of all, by having had this sort of war on masks to return to a reality that simply is not there, has created this sort of discomfort in the population about masks themselves. And it's a problem for transmission, of course, because, now the people that are masking are few and far between. It's also, a problem because now when we have these waves that are unending, we have the New York Public Department of Health saying, hey, New York, mask up. People reply, well, F you told me that masks were not necessary and that the vaccines were great. Vax and relax, yo. Nobody wants to do that anymore. So it's a huge problem of education. And that's because we started on the wrong foot to start off with. If those mask bans are passed, what we're going to see is an actual harassment of people who mask for health reason, even though every single one of those mask bans say, oh, exclusion of health, right? Exclusion are made for health reasons. And it's like, that's just not going to happen. And I was, giving a testimony at the Nassau legislature, and so I got to hear the argument of the actual legislators, and one of the most clever legislator very cleverly asked the question, well, who is going to make that judgment? Is the police going to stop everybody wearing a mask on the street and say, are you wearing the mask for health reason? And then you're going to have to disclose your entire health history to a policeman, or worse, you're going to have to do that to a fellow passenger on the train because now they are aware that there is a mask ban. Because of course, that also makes the news at the top of the news, right? So you're gonna have to say, well, I'm immunocompromised, or I'm blah, 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 or I have somebody I care for who has cancer, right? This is not sustainable. And this is going to create a huge nightmare of a situation. Now, one thing that was proposed, which is a little more tolerable, although I I am completely in the proponents of no mask ban whatsoever, is basically saying, having on the books a law that says if you've committed a crime, so first a crime has got to be committed. If you've committed a crime and on top of that you were masked to obviously hide your identity, either with a bandana or an actual mask, then your penalty is going to be higher. But it's only after having committed that crime, right? As opposed to, we're going to ban masks in a sort of, what is that movie where you're predicting crime? That terrible movie with Tom Cruise. Anyway, that one, right? Is like, are you going to try to
In Minority Report?
Minority Report, that's it.
Thank you to Nancy in the chat for knowing that.
Excellent. So you're going to Minority Report everybody wearing a mask? This is absolutely ridiculous and outrageous that it's even being proposed in its current form. And you know, the reason that it's being proposed are preposterous at best. I just want to remind everybody that when we wore masks and were vaccinated for SARS-CoV-2, one of the things that happened in the height of the mask mandates, right? At the height of the mask mandates, we got rid of one strain of the flu. We got rid of it just because everybody was masked. And that flu just said, oh, well, nowhere for me to go. So it's important to know that mask actually works. Important for us to remind every single one of us. It doesn't have to be an advocacy group. It has, every citizen should remind our and every person actually should remind their local legislature and national legislature that masks save lives. They are important tools in reducing airborne transmission. They are mitigation tools, and they can even prevent, when used properly, a new airborne pandemic, right? If people are wearing masks on the common, or if we get finally a bill which cleans our air up in public transports and public places, we can kill those things in the egg, so to speak.
Will continuously spreading COVID and infecting people eventually lead to herd immunity?
No, it's obvious. We've seen that for the past 4 years. This is not how COVID works. This is the thing. SARS-CoV-2 is a novel pathogen. It doesn't behave like any other. It has its own tricks. It continues evolving. And I hate when people say, oh, it's evolving into a milder version. No, it isn't. It is just as bad as it used to be. The only thing is what we have is vaccines, right? Okay. So the vaccination has actually lowered the rate of severe outcomes, and it has lowered the rate of death, but it's still, you know, the vaccine is not perfect. We're still seeing these waves after waves. And by the way, since we've stopped testing, since we've stopped counting hospitalization and death, and most of all, since we've stopped counting test positivity, we're not really having a good assessment of those so-called waves. But one of the things that if you look at a graph, even the worst of the graphs of the CDC, or if you go on the New York State Health Department graphs, what you see is we are having, since the end of the mask mandates, we have a much higher baseline of cases in between waves than we used to have with both the vaccine and the mask mandates. When we had the mask mandates after the first rounds of vaccination, the cases went precipitously down to a very, very low baseline. But now we can't have a low baseline anymore. That baseline remains high, and then you get peaks.
We had a question in the chat from Rachel saying there are a lot of conflicting studies on the efficacy of masks, mostly due to political reasons, I imagine. And I personally know many people who are incredibly misinformed about mask efficacy. For example, many people believe masks don't work unless everyone wears one. Can you share some helpful resources to dispel these myths? I've looked and it's been unsettling how hard it's been to find.
There are very good resources. There's actually quite a few good resources online that you can find that are kind of aggregates of resources on the efficacy of masks. I actually have a website on which I have slides that I prepared for my college when they still cared about COVID. Like everybody else, they stopped caring. But they have aggregates of studies that you can present to people, and the idea was to educate the faculty and the staff on mitigations and what to do with COVID, and also, you know, the whole vaccines. They needed to know what these vaccines were. So I can share that with you happily if you want. But there are many different sources online that you can go to. The slides that I prepared have some of them, but I I can also share them with Julie and you, Sarah, so that we can post them online after this session, this seminar. But yes. This and your question is very important, because it points out to one thing, is that the government has relegated the education of that should be national to individuals, and that's not what public health is. Public health is circle, underline, public, right? It shouldn't be up to the individual to have to go through a fire hydrant of scientific papers out there that are, you know, but 50% are great, 50% are really shoddy, right? Because as Alan mentioned earlier, a lot of them were produced by people who just literally wanted their name out there and you know, write about COVID because they just wanted their name associated with COVID because there's great funding potential, but that have experiments that are shoddy at best. Yes.
It's funny you mentioned that about how people won't do the work to sort through things, and I remember in 2021, part of the reason I was ready to ditch masking was because I thought, if the CDC this whole time has been the one telling me you have to wear a mask, you have to get a vaccine, you have to stay social distanced, if they're telling me that now I don't have to do that anymore, why would they tell me that if it wasn't safe? And you know, we're now in this weird situation where it's us versus the CDC. It feels like we're going to our friends and saying, hey, you still have to take precautions, and they're like, who are you? You're a 32-year-old accountant, you know, you're telling me something that's different than the CDC. Mm-hmm. I'm not going to listen to you. And I guess on some level, I don't blame them, but it is very much, you know, we're doing webinars like this completely voluntary because the government isn't.
Right. And it is frustrating. It is hugely frustrating. And you know, my spouse is a biologist who works on bats. So we've been busy. But also works on environmental issues, and of course climate change is a huge part of her work. And she used to have these despondent moments, and since the pandemic happened, I now really understand why she is so despondent, because of course people working on climate change have been despondent for a long time. And they're basically the echo of what we're feeling right now. We are being abandoned because the population is being abandoned in favor of profits. And this is the bottom line, right? And it is important to have solidarity. This is something that we've seen in the AIDS epidemic. It's important to have advocates, because without this advocacy and without this solidarity, we're not going to go anywhere. We need to find our tribe, and we need to speak loudly to the powers that be to change things. And it's obvious that we've come to a point in our system where things are broken, and we need to change these things, and we need to vocalize that as loudly as we can. One person speaking loudly is maybe drowned out, but 100 people speaking loudly cannot be drowned out as much. So if we hold together, we can produce the same kind of amazing changes that we've seen with the AIDS epidemic. And we can change the system, because we need to change this. This is not sustainable. And I think people at the beginning of the pandemic realized the problem, and very quickly that realization was just, the powers that be just put a pillow over our head and just said, no. It's like, this is not at all what you think. So there was this current of like goodwill, and like, we're going to change the system, and it's going to be all about the people. And then that was squashed and killed in the egg before people could organize. But it's groups like Mask Together America that can change things, and we're going to need to change them. I won't lie, this is going to be hard, and it's a huge uphill battle that we can't let go, because the alternative is to let our vulnerable people die, and that's not acceptable. That's just not acceptable.
Well, thank you, Dr. Corthals. And, for anyone in the chat who's not familiar with Dr. Corthals, she really, she's walking the walk on this when she's talking about advocacy. She spoke up at the Nassau County meeting. There's a recorded video of her testimony out there. She was part of our leadership team that went to Washington, D.C. to advocate for more public health awareness. And she was a speaker at the Long COVID Day of Awareness in March, which was a great gathering of people who are affected by this. So certainly, we're really grateful to you for all of the work that you do with us, Dr. Corthals. And, you're just one of my favorite people as well. So that's cool too. But
well, I cannot emphasize enough how much of an amazing job you're doing, Sarah, for Mask Together America. And I can't emphasize enough how important Mask Together America is, and how grateful I am to Julie to have found her, and to see her incredible leadership. But also, I don't know how you do it, Julie. Honestly, I don't know how you do it. You are up at all hours and you do so much work. I can't follow. And I'm pretty good at, at multitasking. I'm following behind you, like just running after you. You are an amazing person, and you are all amazing, and Mask Together America, and together we will change things. It's not a question of if, it's a question of when.
And speaking of change, I'm going to turn it over to Julie, because she has some very important advocacy work to share with us.
Thank you so much, Dr. Corthals, for your words. And thank you, Sarah. Thank you, Dr. Robbie, and everyone from our team to be here. Actually, the last few words really make me want to cry. And I put on my mask because I want to talk about mask ban. I hope you can hear me. I apologize if you cannot read my lips, but I really want to talk about this wearing my mask. We are living in challenging times. Hospitals worldwide and even international event organizers are mandating masks again in reducing airborne transmission of diseases. Yet some legislators in the US want to ban masks. They should be normalizing mitigation and creating laws to guarantee paid sick leave or help secure funding to provide underserved communities with free mitigation tools, diagnostic tools, clinical care, and treatments. Instead, these politicians aim to ban masks as an immunocompromised American. I am devastated by COVID spreading year-round without proper public health guidance, protections, or awareness. I am horrified by the likely discrimination that mask bans will lead to. The CDC recommends masks as part of necessary prevention strategies. The agency warns that COVID-19 spread year-round, driven by new variants and decreasing immunity from previous infections and vaccinations. Yet politicians ignore the CDC's guidance. Our president caught COVID, but he didn't mask up as soon as he had symptoms to protect his staff and the public at his campaign events. This sent a terrible message that it's acceptable to infect people. No, Mask Together America promotes a layered approach to mitigation. This country needs an awareness campaign to help people understand the benefits of masking, vaccination, testing, proper isolation when sick, and early treatment. People need education about the chronic illnesses that can follow COVID and other infections. As our group has evolved over the years, we have become a community with a majority of members identifying as part of the high-risk population. As an organization, we are committed to stand with communities with medical conditions and disabilities struggling to safely access healthcare and public spaces. Our advocacy group strongly opposes banning a crucial mitigation tool. Mask bans are unfair, discriminatory, and a significant violation of human rights. In response to mask bans cropping up across the US, starting with North Carolina state legislators who have already criminalized masking, we created an action toolkit and a letter campaign on the Action Network. Other cities and states promoting mask bans include Los Angeles, Chicago, New York City, where I live and state, and Nassau County in Long Island, New York. We together, members of Mask Together America in New York, plan to testify at the hearing on August 5th in Nassau County to stop the first mask ban in New York. We need to be serious about this. Join us if you're in New York, and we encourage our community, especially those at high risk for severe sickness, to use our easy letter campaign tool, which is bit.ly 3XLUHQG, to stay informed and take action safely. We must stop mask bans. Thank you.
Thank you, Julie. And I think it got lost in the chat somewhere, so I will see if I can find it and copy paste it, but here it is. Julie posted all of our links to our various toolkits, all of the letter campaign information. The toolkit itself has a lot of local information. So if you want to see your region and see if there's a mask ban action going on in your area, you can look there and see what actions are going on to help prevent it. If you're not in an area with a mask ban, count yourself lucky and try to help out in other areas that have them working, because once that bell gets rung, it's hard to unring, and this is just going to enable and give ideas to other politicians in other areas that want to prevent masking. So thank you for being here tonight with all of us. Thank you for taking action with us. And we are going to take another 5-minute break. And when we come back, we will hear from Erin Collins, the mask nerd. Meanwhile, thank you all for being here, and we'll see you in 5.
Alan, is it past midnight now?
It's getting to 1 o'clock, but you guys are giving a good talk. But I thought I'd stick around. Actually, I'm pretty excited to see Aaron talk. So it should be good. I'll be up till 2 tonight. But it'll be worth it.
Not the same kind of 2 a.m. you're probably used to, but it's all nerdy that's talking, but that's good.
I just don't know. I've done the 3-button thing.
I can't get over these mask bans. It's literally insane.
It is.
Well, I know.
It's crazy.
It's
haven't seen that in Europe yet, right?
Well, the problem is all the dipshits over here follow your dipshits.
Yeah.
And so it's just going to be a matter of time.
Yeah.
Yeah, because it's not based on anything, right? Like it's just an oppositional defiance as a policy.
Yeah, it's an actual. So their argument is that those were already in place because of so there's been a tradition of the Ku Klux Klan and all of that, and then but those were masks where you literally understand those masks as like the kind of mask you would be wearing at Halloween, right? Like that are full facial masks that have nothing to do with health and that are obviously to hide your identity. But it doesn't matter, doesn't matter to present them with arguments, with scientific arguments. So I was telling them, well, this study is very, very clear in Nature that showed that masks actually are not that great at hiding identity versus sunglasses. They didn't even look up from their pulpits when I mentioned that, because I told them, I said, do you plan to ban sunglasses as well? And they didn't even budge.
I think one of the craziest thing is that they're okay with people, if you're in a parade to wear costume mask, but then they want to say that unless there's a emergency declaration, in one of the bill, it said like unless there's a emergency declaration, which is like they admit that there's a pandemic, then people can wear medical masks. Otherwise, no.
Yeah.
I mean, you allow people to wear masks, costume masks for Halloween, but no, you cannot wear masks to protect your health.
You know what? My body, my choice. I mean, seriously though. Oh, this is
like who do you tell me what I can wear? This seems bizarre. Like, yeah.
It is. It's nuts. And
I don't know if you're too familiar with America, but telling what people to do is kind of some certain people's prerogative. So I am not surprised by some of this, but I think it has a lot of parallels with a lot of other things that people want to tell you about what to do.
How about this? We can just tell the legislatures everywhere that are trying to pass the mask ban, I will stop wearing a mask when you ban guns. I'll never happen.
Yeah, I think it's a fair trade-off. Well, maybe, I don't know. Public health officials might say, I don't know, banning guns might
That'll never happen anyway, so I know.
No, I agree. It's a sad state of but
yeah, it's
exciting to see a group of people here and Julie's work in this space to fight back against the stupidity and get people who are really passionate about it and who understand why it's so important, why personal protective equipment is critical for everyone, in my opinion. I think there's good overwhelming evidence that one of the key things of aging is constant viral exposure. I don't know if any of y'all follow any role from Polybio, and just viral reservoirs being sources of Alzheimer's, being sources of MS, being sources of a huge range of, we classify as autoimmune disorders, but really they're just diseases that we can't trace the origins. And the correlation with the virus exposure is so high, and the list of infectious diseases like influenza, RSV, varicella chickenpox, right? Like all of these diseases that are getting correlated with autoimmune disorders, and you're saying, well, how many of them are airborne transmissible? Almost all of them, right? And you think, this is what the future of the world needs, is if you want to continue to extend people's lives, you have to clean the air. And right now, the tool we have is to use a mask because we're waiting for society to catch up to us. So don't take my tool away.
Yeah.
Or at least put air cleaners everywhere and UV and do all the other things. I'll do that too. You want to do all that? I'll stop. Deal?
Yeah. But let's talk about bleach. No, I'm not kidding.
just open the body up.
Yeah.
On that note, welcome back, everyone. We are going to move on to our final presentation of the evening, which is with Erin Collins. It's a discussion called Let's Clear the Air on COVID, a clean air discussion, round 3, because Erin has been here so many times before and we just never run out of questions for him. So thank you for coming back, Erin. We really appreciate having you here. Erin Collins is a mechanical engineer with a background in aerosol science who's been testing and evaluating masks and sharing his findings on YouTube and in an ever-growing Google Doc. Erin is also a passionate advocate for clean indoor air, having helped form Open Arrows and the OSLUV project, tackling mitigation and solutions to equitably bringing clean air to those most impacted by the COVID-19 pandemic. Erin Collins is a mechanical engineer. I think I just said that, so I'm gonna not read the same thing twice. Thank you so much for being here with us, Erin. As always, thank you for hailing from my great state of Minnesota, where we have wonderful weather today. We're going to jump right into questions. What steps do our public health agencies need to take in order to prepare America for a new airborne pandemic?
I think the good news is the same steps that we need to do for the current epidemic, right? So I think when we think about what COVID is it took advantage of the fact that we don't clean indoor air. And so whether it would be COVID-19 or H5N1 or some other airborne transmissible disease, they all have the same mechanism. And so really that Swiss cheese model comes back to play, that we need to think about, testing. We need to think about mitigation tools that are a variety, that might be vaccines to help reduce the probability of illness, or hopefully at some level to adjust the dose response function. We need to think about clean indoor air, whether it's portable air cleaners and whether it's far UVC at some level, as well as ventilation, of course, is very important, as well as Alan had talked about the importance of that in the context of COVID. And I think it's also important in a lot of other aspects of just having good air quality, right? We don't need high CO2 for a lot of reasons, not to mention the addition of deactivating viruses a little faster. And then we have to have some personal mitigation tools. And I think masks are very important, right? So when a new pandemic starts, we don't necessarily know how infectious it might be. And so tools that we can use to both have source control, which we've seen some really good studies. Don Milton's team out of University of Maryland had that new study that came out that showed, like, they kind of classified as like N95s are the best, but like it showed that like better masks do great source control, and better masks also help reduce your inhaled dose. And so together, those two things together can significantly reduce the probability of infection. When you stack all that together, that's how you stop a pandemic. And it gives you time to think about, okay, what other tools and techniques, how contagious is this, what the mechanisms, and that's what you do. You're buying yourself time to come up with better tools, better vaccines, better everything, and saving people's lives along the way. There's no reason that we had to have as many deaths in the pandemic that we did. And it's a reminder every day when you think about how many people have passed away in the last 3 years that in many ways I don't think needed to, or could have been saved. So it's about the Swiss cheese model. We have all the tools. We just need to convince public health experts at this point that there is value in stopping this. And I think that people here, it's very important to kind of combat the convenient lie that was told, which is, oh, it's mild and you're only going to get it once, right? And I think people are starting to realize that oh, that's not true. And now public health has a little bit of egg on their face. So how do we get them, just like WHO acknowledging airborne transmission, how can we get them to look at this and treat public health as they should, which is that it should be about improving life, happiness, mortality, reducing mortality. And one of the tools is to do that as clean indoor air. So long answer short is we got all the tools, let's use them.
Don Bayer reintroduced the Airborne Act. Does this bill proposed meet the threshold to prevent transmission of airborne diseases?
So I think it's a good first start. I think when we look to what legislation we want, in my opinion, from my perspective of the world, is that we want to be a little careful about some of the things. So there are a couple of things in the act that I think heart is in the right place, but I think we need to be careful about how we legislate. One of them is saying, okay, if you install MERV 13 filters, you can get a tax reduction. Okay, that's great. MERV 13 filters are really good, but I think we want to be careful about legislating specific technical requirements. I think the use of consensus body standards to help form tools, like we think that in building codes, right? In building codes, you have a consensus body standard, some building code that comes out and they update them every few years, and then a municipality just adopts that version of the code. And that allows you to have this continuous progress. So I think we have to be careful about writing in technical requirements into the legislation. I saw some of this with some Michigan clean air stuff, that they were writing in that it had to be HEPA. And I think that if you look at air cleaner data, I don't think there's any justification for using HEPA. It just needs to have a good clean air delivery rate, right? We talk about CADR, and all that matters is CADR. We don't necessarily need it to be HEPA. And if you write it as HEPA, you like lock in this sort of series of technologies that later on you might have better solutions that aren't, and now states like Michigan couldn't adopt them. So we need to use consensus body standards. ASHRAE 241 is almost in the process. I'm not an ASHRAE member. That's the American Society of Heating, Refrigeration, and Engineers, and so the people that do HVAC. And so getting consensus body standards updated and getting governments to adopt the consensus body, especially in the US, to adopt that is really the tool that we need, because there's also a broader perspective about infectious disease, which is ventilation through 62.1, and then, ventilation through 62.1, infectious disease through 241, and you can kind of dial that into what you want for public spaces. So maybe you don't really want to legislate what people do in their personal home. I think there's a lot of issues around trying to legislate personal homes, but think about where public spaces make sense, where schools make sense, and how do you structure that. So I think legislation needs to be based on consensus body standards, which means consensus body standards need to get their butts moving and get these standards out and start to figure out how we actually design the future for clean air.
If a building met the ASHRAE standard 62.1, which is what the air quality standard Virginia Congressman's Airborne Act promotes, does that mean it's safe to unmask and gather during an airborne outbreak?
So in general, I don't think so. So there is good things about ASHRAE 62.1. So for those who are not familiar, ASHRAE 62.1 legislates ventilation, where we mean fresh outdoor air coming into the space. So if you have, like me, I'm exhaling CO2 right now, we need to dilute that out and bring fresh air. And that's what 62.1 does. And it does it on a per person basis, which is good. However, when we think about infectious disease, you can't do that all with ventilation. You shouldn't do it all with ventilation. You can, but it's very energy intensive, and it's going to take tons of air handling systems that need to be upgraded. And so ASHRAE 241 is looking at, okay, how do we treat infectious disease differently than just outdoor air? And outdoor air is important. That's going to lower CO2. Lower CO2 is good, so we're paying more attention to the spaces. It's very good evidence. There's a great study that showed that they took like 6 office workers or 8 office workers, a group of office workers, they exposed them to different levels of CO2 and then gave them standardized tests. And the people that were at like 2000 ppm, which is not really that high, you do see that in some spaces, in decision making, they went from like the 75th percentile to like the 25th percentile. So they went from like pretty good people at making decisions to like, they're really bad at decisions, right? So maybe CDC has some high CO2 levels in their offices. So we want to have fresh ventilation come in with 62.1. But when we look at infectious disease, different problem. We need to remove these viral particles, and we can remove them with fresh air coming in because it's likely not to contain any virus. It's going to be very diluted by the time. Or we can say that filtration is equivalent. So if I have a HEPA of air cleaner and I have fresh air coming in, both of these are providing the equal amount, or could provide the equal amount of clean air. And that's important because it's going to be, as you look forward to the future of indoor spaces, I think portable air cleaners are going to be probably one of the big players in the space because they're infrastructure agnostic. You don't have to go update all of the building material, and you can get to the ASHRAE 241 numbers that we need to with some, I think, better designs. Right now, air cleaners are a little bit too small for most spaces, but better designs are going to really allow us to target that. You can easily put these in classrooms and get the sort of cleaner rates that we need without having to like spend millions of dollars in HVAC. So the answer is 241 for infectious disease, and we still should do 62.1. We should do that because we could make our students smarter, right? We don't, someone sitting in a poorly ventilated classroom is going to struggle. They're going to learn worse, and you're going to try to make up for that. So ventilate, that's good. That's going to make our students smarter, and do 241 so that we don't have infectious disease. So we're not missing school because they're sick. We're not transmitting it to parents who then are missing work. And most of all, we're not getting everyone sick and having to put, a toll onto our workplace. Or if you're immunocompromised, possibly you're putting your life on the line. So I think, to me, these two things have to happen together. They both are part of clean indoor air, and we can't say you do one or the other. We have to do both, and we have to do it energy intensively. So we have to, or without being energy intensive. So we have to think about how do we do it more efficiently. But that's the engineering problem. Give me that problem any day of the week. We'll come up with good solutions, but let's put it first in the legislation so there's good justification for it.
So if it's important to do both, why does the Airborne Act choose 62.1 instead of 241, which was created for infection control?
So I'd have to look up where 241 is. I do not think that 241 is officially and approved all the way through the committee. So it's partially there. There's these final approval processes where it gets broad adoption. I haven't checked in a while because I'm not part of ASHRAE, but I do not believe it's fully adopted yet. So you need that consensus body approval before we can start to add it to legislation. So they need to finish it. It's been floating out there for like 2 years. Just let's finish it. Doesn't have to be perfect. Perfect is the enemy of good. So that's my pitch. That's why. So we need consensus body standards to get their butt moving, and we can get some of these problems solved.
The Airborne Act would use the tax code to give building owners incentives to perform IAQ inspections and upgrades. Specifically, it would incentivize commercial building owners to conduct IAQ assessments of their properties, providing them with a $1 per square foot tax credit, not to exceed the cost of conducting the assessment. I can kind of see, I feel like you're fist pumping there. What are your thoughts on this proposal?
We absolutely have to incentivize businesses to do this to start with. If you think about it from a broader perspective, just like building the first subway line, right? It doesn't really go that many places, right? But as you develop a network, it has value. And the same thing, if you clean one school, you're not going to see a huge change in your entire community. But if you clean all the schools and all the public spaces, we can begin to start to get the R0 or the replication number of many of the viruses much lower because there's fewer opportunities for it to transmit. So we really have to do this in the broad swath of the community. So how do we do that? How do we incentivize people? Well, I think money is always a good one. We should just do it because we're good. We want people to be healthier. But unfortunately, building owners are kind of dictated by finances. And so having some tax incentive or whatever it ends up being, I think is going to be a powerful tool to get people to adopt this in a much faster time period. Because the longer we wait, the more suffering we put onto everyone.
The Airborne Act would also incentivize commercial building owners to upgrade their HVAC systems to reach the ASHRAE standard 62.1 and a minimum efficiency reporting value, MERV, rating of 13 or better for their properties. The tax credit for upgrades is equal to $5 per square foot of property affected for air filters and $50 per square foot for HVAC systems. What are your thoughts on that proposal?
I think it's a good start. I think having conformance to 62.1, absolutely we need to do it. I would actually even argue that if I had a magic wand and I could go into ASHRAE, I would be like, look, we should put the ASHRAE values back to where they were, I think, in 2004. They came down in the past. Over the standard gets updated periodically, and they lowered the fresh air rates in many years back. I think we need to return back to those, get to these ppm levels that are much lower. And the other side, MERV 13 is good. It's really what it's highlighting is a big problem we have. And actually, someone had linked a paper that was just in Science magazine, and I would recommend everyone take a look at it. It's all about clean air for air pollution, also a context for COVID. And there's a couple key pieces in there that people like Lydia Morowaska and others have highlighted, is that we lack consensus body standards for indoor air quality. What should the indoor air quality be? So if we think about requiring a MERV 13 filter, that's a good step in the right direction. But really, we want performance targets. Like, what should indoor PM2.5 look like? What should we do for infectious disease control? And how can we make sure that's not just add a filter, but make sure there's sufficient flow through that filter too? And so we're highlighting that as a standards organizations are missing and public health are just like indoor air quality. And if you include humans as a source of pollution, which I do, then they're missing a huge section of regulation. So, what is the best answer in terms of government? I try to stay out of politics as much as I practically can. What's the best way to legislate it? If I had a magic wand, consensus body standards that specify those performance of PM2.5 in spaces, CO2, and we can measure it all. It's like maybe like $100 a room these days to do like a pretty decent air quality measurement, and that has it updated to the cloud and all that stuff. So we have like all the tools to do that. We just need to set the standard levels and have mechanisms to enforce that through building codes, whereby consensus standards help set the standard for the building code. So is it bad? No. If you came to me and said I had nothing or that option, I would pick what they're offering. But I think we can do a lot better, and I think we need to. And I think indoor air quality is going to be like the next frontier of people fighting over regulations, and we need to do it. And we have to include humans as a source of pollution as part of that.
So the Airborne Act would look at creating a Department of Energy and Environmental Protection Agency voluntary certification program for property owners to certify that their properties follow the IAQ standards outlined above. What do you think about that proposal?
I think that's great. And it's exactly what we need. Is we need someone that sets the standard and then can, in some level, incentivizes it, whether with the, do we give them a carrot or do we give them a stick? I always like using the carrots. I think that's a good technique. And so I think in general, I think the plan is what you could do with it. You don't have consensus bodies in space and you want to take action now. So I'm not necessarily opposed to it. I just wish that we had consensus body standards, and I think the EPA, and I think there's actually a legitimate discussion that needs to happen, especially in the US, is who legislates, what government agency is in charge of indoor air? Is it the EPA? Is it going to be the CDC? Is it going to be some other party? Is it Department of Energy? I think that the problem is that there's no one person that fits nicely in that bucket. And somebody in the government, whether by our encouragement, figures out whose umbrella it falls under, but we need to do it now. And so this would be fine with me if they wanted to run through the Department of Energy and EPA as a sort of co-authored or co-affected group.
The CDC's HICPAC initially approved surgical masks as respiratory protection for healthcare workers exposed to infectious diseases in 2023, as the committee was tasked to update the infection control guidance for healthcare. Do you think that surgical masks should be recommended for source control of infectious diseases in healthcare settings?
That's an easy one. No. I think there is overwhelming evidence that, while they are better than nothing, that they're not that great, and we have way better tools at our disposal. I think, again, Don Milton's work that was just published, and I apologize, there is actually a lead author, and I can't remember the lead author's name, so I do apologize. But within Don Milton's group, Kristen Coleman was part of that too, looking at using the Gesundheit, which was allowed them to directly measure viable virus outside. Well, actually, is it viable, or they didn't do PCR. So I think it is viable virus that they were looking at. So they did direct collection of this. And then they looked at, when you add mass to this, what's the reduction in that rate? And so that work had shown, again, that surgical masks weren't that great. In fact, they showed that cloth masks were better than surgical masks, right? And that's because surgical masks, while they have good filter material, lack fit. And we know that fit is like the most dominant part of when we talk about either inhalation or exhalation. They both work the way. We want all the air to go through the filter, not around the filter. And so surgical masks aren't great. We can do much better. I think there is an honest discussion that we need to have, which is N95s are great, but our current designs of N95s typically have high sealing pressure, so they're quite tight to the skin. And if you have to wear that 8 hours a day, and we don't have good standards or requirements for about wearing masks 8 hours a day, because currently NIOSH doesn't regulate. I mean, you could make a mask that you can only wear for 5 minutes, and that will pass NIOSH, right? They don't require you to really think about the human effects. And so I think that there is a balance that we can think about, which is, if we can get a good sealing ear loop design that fits a wide range of faces, and we get 90% reduction or 95% reduction instead of 99% reduction, like, is that a good trade-off with adding ventilation and filtration, that we overall reduce the virus load so low, but allow a little bit more comfort for the wearer? And so I think we need to really think about, when we talk about hospitals, we have to think about comfort and what people are going to be able to wear for 8 hours. And that's really critical to design. And so I think innovation is needed. But if we continue to say you could use a surgical mask, no one's going to innovate, because those things are so cheap and they don't do anything. And so the death of the surgical mask, I think, is it's unfortunately the sort of holy cow or a grail of the medical world in which they like put it up there, and then as soon as you look at any of the data, it all falls apart. Like, wait, it doesn't really work as inhalation. Oh yeah, no, it only has like a fit factor of 2. Well, it works for source control for droplets. Like, well, kind of, but for aerosol, it doesn't do anything. And we know that COVID's transmitting via airborne aerosols, or these respiratory aerosols. Well, yeah, it kind of doesn't do that either. But it does something, right? We got to keep wearing them. So I think we have to go and beat up that surgical mask, myth that exists, that they're effective. And I think that the real positive thing was to see so many people come together for that HIPAC committee who really pushed them to reconsider that. And I think that it was great to see so many voices out there that stood up to say, hey, look, how can you have a committee where you have nobody expertise in airborne transmission of diseases? How can you have a committee in which the surgical mask, the data that you're trying to use is not supported in any way, right? No one goes and does asbestos wearing a surgical mask, right? They would be like, you're insane. There's no field of any work in which a surgical mask would be allowed, except when it comes to disease transmission, and probably the most important place to do it, a place where people who are seeking care are coming and are most likely to be, more likely to be impacted by a respiratory disease. So thanks to all the community that did that. It was awesome. I mean, it was awesome to see that come together. I had a very small part in that. And it was just great to see so many people, so many greats in the industrial hygiene space, and just, they really just knocked that one out of the park. Now let's see if the CDC takes action, a whole other issue, but it's great to see a community come together to do that.
So given that, how do you feel about the government website for NIH Recover, its initiative for long COVID, showing people wearing surgical masks?
It drives me nuts. It drives me nuts when we have so many better tools. And I think that it's a broader problem in the medical space. How do that surgical masks are kind of viewed as a tool to stop this because it comes from the droplet dogma world, that we're stopping droplets, and surgical masks are probably and are effective at stopping droplets, but that's not the mechanism of transmission. So we have to abandon that, but it's going to take it is deeply embedded into the medical space, and there are work in progress to do that. There's ASTM's working on a bunch of standards to look at total outward measuring the leakage of a mask to see how well it is effective at source control. So there is work in progress, and that will slowly help to chip away at showing that surgical masks are not effective at source control. They're not effective at inhalation control. So why are we talking about these things? Why are we hanging drapes off our face and expecting them to do something magic?
The current CDC's respiratory virus guidance didn't include masks as part of its core prevention strategies. The core strategies are immunization, hygiene, steps for cleaner air, treatment and isolation until 24 hours after symptoms and fever-free, and then masking for the next 5 days. Studies show that people can be contagious with COVID for over 10 days. Do you think that masking for just 5 days is adequate in preventing outbreaks in workplaces and schools?
I mean, I think it's a tough one in this space. So first of all, I think in general, they should be talking about masks as a tool to prevent infection. That we keep viewing this as a source control tool. So, if you're infectious, then wear a mask and then wear it for 5 days. And I think that at least they're encouraging some mask wearing. So that's an improvement for where we've been in the past, but it is certainly not sufficient. I think that the argument that I would make is that we have tools to do some testing. I don't quite understand why they're not advocating for more, testing on a rapid test. And then, we keep doing symptom free. We have tests, and rapid antigen tests, in my opinion, are, if done properly, which I guess is probably why they don't like this, but if done properly, really do give a good inference to how infectious you are. They're not really good at, in my opinion, not very good to tell if you have COVID, right? The problem is they're not good at early detection. So you're not going to get treatments like Paxlovid or other things if those would be life-saving for you. And they tell you when you're infectious, when you're already, most of the time we're having symptoms like, oh, wow, okay, yeah, I have COVID, but I'm not going to what did that do? However, they are super effective, in my opinion, at finding when people are infectious. So if you're trying to figure out when can I exit and go back to society or wear a mask in that period, it's you should say, hey, I test negative on a test, and then I'm going to wear a mask for some period of time after that as a good safety measure. And that's how you get exit. So we actually, again, we have the tools to do it. We're not using them. And I'm really surprised that we haven't started to think about how we use rapid antigen tests as metrics for people's level of current infection and use that to introduce people back into society after they have cleared an infection. So in general, yeah, you should wear a mask for 5 days at least. Be nice to everyone else around you if you've had it. it's really good idea to not spread it, and use rapid antigen tests to give a clue for you about where you're at in the disease. And if you're testing, 2 negatives in a row in like 48 hours, like the probability of onward transmission is quite low.
We want to encourage the CDC to redo the core prevention strategies for airborne viruses. What are your key concerns and recommendations?
I think the fact that they're starting to talk about clean indoor air is important, but so far it's been like open the window, which I think is like not really helpful to people, because one, what if there's wildfire smoke? So like, okay, so I gotta open my window and bring in shitty outdoor air, which is not good for me to breathe. Or I can choose an infectious disease. Like that's a great choice. The answer is like there's not good, clear guidance about how do we use and how do we create clean indoor air. And so that's been really frustrating to me, because I think that's one of the key cornerstones about how we solve this. I mean, I love masks. I think masks are very effective, but for a segment of a large portion of the society, the personal burden of the pandemic, they're burned out. Like, I don't want to have to carry the burden with me, because I just want to go shopping and do stuff. And like, a part of me understands why that I don't agree with it. I think we could, as a society, we should work together to solve these problems. But at some level, I can understand why they feel that way. So clean indoor air is like sort of this non-personal requirement. You buy an air cleaner and you set it in, but like, how big does it need to be? Where should we place it? How do we use that in community settings for like schools and all these other stuff? And so I feel like there's a whole lack of guidance about how do you do clean indoor air? And I think that telling people to open the windows is a good first start, but is really not that effective. And if it's not a windy day, it's actually not even that effective. Like, you get some fresh air, but you're not going to get nearly the levels that you would want if you had, if you want 4 to 5 air changes per hour, or in the ASHRAE world, it's clean air per person. You kind of want like about 40 to 50 CFM per person. And so I think that when we start talking about ASHRAE and these type of things, we should be talking about how do you select an air cleaner based on how many people are you going to have at your party, right? Like, we don't talk about that, but we could. ASHRAE tells us, oh, well, if you're going to have 5 people and you need 50 CFM clean air, each room that you're going to have the people, and you need 250 CFM air cleaner in that space operating at that flow rate, and you can significantly reduce the probability of infection in that space. But they're not talking about that. They just say, open a window. So that's what I think we should do, is talk more about clean air per person and starting to create tools where people can start to select air cleaners for infectious disease control, as well as for air pollution as well.
What should be the standard for a COVID-safe filtration system for subways?
That's a tough one. I think the answer is, so I got to preview these questions beforehand. And this is the one I was like, wow, I have to really actually think about, what did you do for a subway? Because when we think about subways, lots of people, period of duration could be pretty long. I mean, sometimes you might be on a subway for 20 minutes, right? So that subway car could have an occupancy density pretty high. So I think, again, the ideas of ASHRAE 241 need to be extended, not just to building locations, but we need to think about subway vehicles, buses. We have to think about transmission and where all the people spend lots of time packed together, right? So airplanes is definitely one. Buses are a commonplace. Subway and transportation, in which everyone has to use them, right? No matter what you do, you're going to likely use some form of public transit, or I guess I would put airlines as public transit, but hopefully you understand what I mean, that people are going to interact with this. And so buildings are also important, and our transit network needs to do it. And I think we need to create a sort of, higher level idea of that we should be doing ASHRAE 241. So we want clean air per person. So if you got 50 people in that car, you need a lot of air movement. They do it in airplanes. Subways, I think, are hard because they're not really always resourced appropriately, especially now in New York without the congestion tax and the whole plan about how they were going to finance their subway system with that, right? So they're under financed. So I think that we have to start treating the cost associated with the pandemic in places that it actually can be used to reduce that. So how much did the pandemic cost the world, and how much money should we spend to stop the next one? And I think we have to think about those spaces, and we have to put an emphasis that not cleaning the air in the subway, which can create a form of transmission that happens there, that has a cost to society that we need to offset, and we just need to build it in. How do you convince people to do that? I think that's, to me, the $1 million question right now. I think indoor air quality is becoming a topic that more people are interested into. And so pitching things as clean indoor air, from not really talking about infectious disease, but clean indoor air for health reasons and stuff like that. And infectious disease comes along for the ride until people can kind of like get over the issues around trauma around COVID, which I understand it was a traumatic event. So I'm not trying to belittle that. It's just that it's hard to talk about it because it's hard for us to all process that hellish few years of where we didn't know what to do. And so I think we frame it as clean indoor air, and I'm getting way more traction with people who don't care about COVID when we talk about clean indoor air, or talk about other mechanisms about, life and aging and the associations with the viral exposure as being a much more effective way than just talking about COVID. So that's kind of what I've seen successful. So if other people are looking for ways to do it and pitch their schools about clean air, talk about wildfire smoke, talk about all these other things, talk about illnesses that are influenza, and you can mention COVID, but just don't focus exclusively on it. It seems like I've had trouble with traction in that space, but talking about clean air and talking about air pollution is much easier and much more accepted by everyone, which is unfortunate, but the world that we're in at the moment.
I've definitely seen commentary that suggests that, the wildfire smoke, of course, is a climate crisis and it's a horrible thing, but the timing of it happening during these bad years with COVID is getting people more interested in clean air, which is a weird and roundabout way to get them interested in it. But I think because there are fewer wildfire days, then, COVID's here all the time.
Right.
It's easier to get people to think, oh, what can I do to clean the air for these couple of weeks of the year that I might need to?
Oh, I was just going to say, the other thing that I find successful to talk about is just illness in general, missing work, kids bringing home sickness. If you talk to other parents, especially in the school space, and you're just like, yeah, isn't it weird that kids always bring home all these illnesses? Like, yeah, and you're like, it isn't weird that all these respiratory viruses also like transmit. Yeah, we should clean the air. And then kids won't be so sick. And they're like, oh, I like that idea. If you say, let's do it for COVID, like, but if you just talk about it from the idea of like, you're going to miss less work, you're going to be sick less often because your kids aren't sick. There's all these mechanisms of sort of talking around the subject that I think I found much more success in than directly saying, hey, the thing that killed 3 million Americans is one of the leading causes of death for like the last couple of years. That doesn't get much traction, but wildfire smoke does. So just use what works, I guess.
It definitely feels like there is it's kind of a boogeyman to say the word COVID, which is unfortunate. I feel like I was having conversations with people that were trying to tell me why they weren't taking mitigations. And then somewhere in that conversation, it came up that I hadn't been sick in years. And they were like, oh my gosh, you could sell me any supplement right now, anything, what are you doing? Are you taking elderberry? And I was like, I'm just wearing a mask and not going places during COVID. And then that killed it because I mentioned COVID. Yeah. But no. In general, yeah, if you can frame it as a positive, if you're health conscious, you should care about clean indoor air. Then it's more of a, oh, we're working towards this thing rather than trying to avoid this negative.
Yeah. No, agreed. Yeah, I think that's very important to frame it that way. And so people who are advocating, I just would really push you to say, if you want to, from what I found, now maybe society will shift over time, but what I found effective now is to not talk about that, but talk about illnesses that are not that. Talk about that I think it would be really cool to have Amy on here. I can see if I can help with that. Amy Pearl does. I mean, it's just a great talk about all of these viruses and how you can really tie it to aging. So even if you don't want to, so some people don't want to talk about, illness and disease transmission, but everyone wants to live longer, right? And so connecting these two things together, I think is an interesting way of framing this so that people listen, even though they should listen, but this is where we're at.
No, I'm very interested to look into those resources, because even when you said that, my ears perked up a little bit, like, oh, anti-aging. This is something that we spend so much money on, as certain people who are sometimes femme will spend a lot of money on that. And it could be as simple as, instead of buying a crazy expensive moisturizer, we're just wearing masks.
I can give you a personal anecdote. I don't know what the time is. I'll keep it a little eye on it. But I can give you a personal anecdote that I had a long conversation with someone who got to see some of Amy's talk and hated masks, didn't want to wear masks. And we started talking about air travel. I was like, if you're going to wear a mask anywhere, wear it on the plane, like to your vacation, right? Like, there's a lot of good reasons to wear a mask, but I'm not going to convince that person that. But like, when you start talking about like, you're going to go on a trip and this trip's really important with you, and you're in a crowded spot with a whole bunch of people and strangers, and you don't want to get sick before your trip. And we can talk about all these mechanisms of transmission, not just COVID, but influenza, RSV, chicken pox, but I don't really talk about too much, measles and rubella or mumps, a whole bunch of airborne transmissible diseases that all are correlated to these autoimmune disorders. And you're like, you can just wear a mask for 30 minutes or an hour on this plane, and you're going to significantly reduce the probability of getting infection and not be sick for your vacation. You kind of start talking them through. They're like, you know what? I do have some. I mean, it kind of makes sense. I probably should wear one. if I'm only going to wear one, like I should probably wear it for there. And you're like, they start putting the pieces together, like not getting sick is a benefit. It's not, you're not flexing your immune muscle. Your immune system is not a muscle. It is a tank. You know, it is a volume of fluid and it gets depleted. Now you can make the volume of fluid bigger. There are some medications, there are some stuff that people are kind of playing at for like anti-cancer stuff like that. So it's not like a fixed volume, but it certainly gets depleted over time with constant exposure, or with infections and other aspects. So not a muscle though. So I think those kind of communication ways of framing in a different framework can really get people on our side. And even though we want to do it for the most transmissible disease, that all of the other discussion can help bring the, make the tent bigger. And so people that want to come in for wildfire smoke, welcome aboard, because I should think you can wear a mask for that too.
Yes. In fact, in my neighborhood, sometimes that's the only time I see masks is on wildfire smoke days. So I'm like, hey, great, whatever will get you there.
Yeah.
But you mentioned planes. What is the CO2 level that's acceptable on a plane? Even though the recirculated air on a plane is filtered through HEPA filters, you're sharing the air with lots of people for hours, especially during boarding when the AC isn't in operation. It's been recommended that the air conditioning systems of airplanes should be on during boarding and during disembarkment to, disembarking, to minimize risk for SARS-CoV-2 transmission. Air filtration and ventilation helps reduce viral loads and the risk of exposure. So yes, all that to say, what level of CO2 should we be looking for on a plane?
So I think when we talk about, Alan's data is going to make a good evidence about why we should lower the CO2. But like in theory, you can have high CO2 and still have very low rates of transmission because filters act to remove the particles, but not necessarily the gaseous output of CO2. So we need to dilute that with fresh air. I think the answer is planes definitely need to have better CO2. I can't imagine being at 2000 ppm and flying that plane and having to make, like, everyone's life is on your hands. And like I said, there's evidence that high CO2 levels make you bad decision maker. So if I was just doing this for the safety reasons alone, we should have good low levels of CO2. It's also going to make you more comfortable. Now, convincing airplane manufacturers to do that is the reason that they kind of skirt the way around it is that it takes energy to bring that. I mean, the air outside is very cold. It's like you're on the airplane, so minus 70 degrees Fahrenheit, which would be like, oh, got to go to the Celsius units, which is going to be like negative, like 50 something degrees C, 60 degrees, 50 something degrees C. You have to bring this really cold air in. You have to heat it up back to our temperature. It takes a lot of energy to do that. And so all about airplane travel is all about fuel efficiency. It's like one of the most expensive parts of air travel is burning fuel. So they're very hesitant to want to do that. And so I think there should be some legislation. Again, when we talk about public spaces, we talk about buildings, but we also need to talk about our transport systems. And we should set some minimum levels for CO2, or definitely some higher levels. And 2000 ppm on an airplane to me is like, you're making bad decisions. That's unacceptable. In terms of disease transmission, airplanes are not terrible when they're in the air, but they're not great. I mean, they do have pretty high CADR levels, or pretty decent CADR levels. They have very high ACH because the volume is very small. So turnover is very fast, but clean air per person is not amazing. I certainly would not probably go without wearing a mask in an airplane now, for surely not in boarding and disembarking, which we'll talk about next. So the answer is we should do better on CO2 levels, but CO2 levels alone don't always tell us what's happening with the filtration. I think Alan's data shows that we should be doing that. Dr. Haddrell's data shows, look, we got a lower CO2 level because that actually helps reduce the viral infectivity for that period of time. So it's win-win. There's no, like, people are paying attention better and we have less disease transmission, like sign me up any day of the week. I think when we think about where are the risks in airplane travel, they're supposed to hook up this external like HVAC duct that they plug in the side of the plane, and that's going to cool the airplane and do all that. In not all countries do that. I was just traveling all over Europe for the last like 25 days. I've had to take a couple flights. Some they did, some I was sitting, waiting boarding and just sweating bullets. It was so hot in there because they didn't hook it up. And those periods of time from when you're at the gate, when you're starting to heavy crowds, you go into oftentimes into I'm blanking on the term for the ramp thing that you walk down to, right? The ramp, which has no HVAC at all. And you stand in there for like 15 minutes with 50 people all sitting in there with no ventilation. You get on an airplane, often under ventilated at that point, high occupancy density, takes 20 minutes to get everyone on the plane. That's the period of really high probability of transmission because you have duration and you have density. When you get up to cruising altitude and that air is flowing pretty good, the transmission risk gets down. And there was a recent study that they kind of show looking at masking and air transport, and not an amazing study because I would love to see a lot more sample size. But of the sample size that they did have, they showed that the people that wore a mask on these airplane trips did not get transmission of diseases. Other people, it was kind of a little bit all over the place in terms of whether they were seeing it, not seeing it. And that's a pretty good evidence to me that like masks are effective at stopping disease or reducing the probability of getting a disease. But the airplane, once it's in the air, once the seatbelt sight goes on, like it's less dangerous during that period of time. And then when you come back down, you land and disembark. Again, we're doing the same thing again. Lots of people, not a lot of air movement, and we're going to wait for everyone to unload. We're hopefully the off ramp side of it, getting off the ramp is much faster usually on the way out, so it's a little less risky. But I think in general for travel, I highly recommend wearing a mask even in the airport until you get to your destination. I mean, if anything, for just not being sick during your trip, because usually you're on a trip for something fun or for work, which means it's really important because you got a bunch of meetings or whatever stuff scheduled. So it's one of the few places I think that it's easy to convince people to wear a mask. And like, to me, if you're going to talk to someone about masking and you want to pitch like, look, just think about wearing a mask. You're only wearing a mask for 30 minutes. Do it before you board the plane and when you disembark. You're going to buy down like 80% of your risk of disease transmission during these period of times, and for the minimum amount of mask wearing. And those are then you get this like just that little baby step of like, oh, I guess maybe that makes sense. And then they start to see like, oh, these aren't terrible. Like maybe I'll wear it when it's like high rates of COVID and I'm going to be packed in with people at some place, right? You get these little baby steps where people start to realize that masks do work. They are effective and they're not as much of restricted as we kind of have associated them because of the pandemic and some of the failed response in that space.
Is the filtered air while you're in flight safe enough to take your mask off?
Well, it's a risk discussion. So in general, I mean, when we talk about safe, it's implicit to some level of risk. I think that for me personally, I consider myself in many ways of life a risk-seeking person. I recently smashed into a stop sign and was in the hospital for a little while.
Gosh.
Don't do that. Yeah, I have a nice scar on my collarbone now. I got a metal plate in my collarbone, and I had a huge hematoma on my leg and some knee damage. But so a lot of things I do, but I would wear a mask in an airplane, even though you'd think like this person's crazy and like to ride mountain bikes and do stupid stuff. But here I am talking about wearing a mask in an airplane. And I think the answer is that there's always inherent risk. And airplanes are difficult because one, typically you're not choosing who's sitting next to you. And you think about, and there's been a lot of like more and more models and some data that recently came out where if you look about where disease transmission is happening, it's happening near the infector on the airplane. If you're adjacent to the infector, you have a much higher probability of yourself being infected. And you don't pick you can pick your seat, but you can't pick who sits next to you, right? You don't have control over that. And proximity in airplanes is very tight. You are very close to people. And so I think one of the things that Dr. Haddrell's data has really emphasized, and I don't think is underappreciated, is like short range transmission like goes way up in that data. Like close proximity, short range transmission is showing that really it's going to be much more likely. I fit some recent models to that. And basically the answer was like, you know, from a broad far field transmission perspective, like doesn't have a huge effect, but short range transmission is like you got to think about tools and techniques to break up short range transmission, or you're going to still have that being a viable mechanism of transmission. So short range transmission is going to be important on airplanes because they're just like your head's like right there. They look over and they talk to you. You're going to be more likely. Once the airplane's in the air, it is less risky because people aren't talking. So when you look at how much emission people have, and aerosol scientists are lazy, so we like to talk about quanta, which is this idea of like probability of infection, where we kind of lump all of the effects of particle size and deactivation and how does it decay over time. We kind of lump it all together. It's just like, what's the probability of this magic particle that represents infection? And when we look at that for talking or speaking, you're seeing 2 or 5x increase in emission. And the nice thing about airplanes in some ways is that people are quiet. So there is some kind of things that are balancing out. But in general, I would recommend you wear your mask the whole time. I don't think it's that uncomfortable wearing a plane. We're a really good high breathable mask. We have so many great options out there. Wear it on the plane. It's really going to limit your transmission. I do think that the period of time, in the flight, depending on the length, international flights that are really long, even though the dose comes way down, the exposure duration is much longer now. So I think that's something that we have to always think about, right? We have to think, what is dose? And dose equals the concentration of it and the exposure duration. So even if the long haul flight has really good ventilation and they're really reducing the concentration, but your flight's 10 times long, it's a 10-hour flight versus an hour flight, like effectively you get 10 times the dose than you would on an hour flight. And so that is still an important metric. So I think the answer is wear a good mask on airplanes. There's not really any technology that I see out there right now that is going to be able to tackle that particular use case, except for masks. You can add more ventilation and more filtration, but it's hard to break up short range transmission. It's hard to add more without becoming a thermal discomfort where you're like, I mean, planes are already cold, you know, feeling the wind blowing over you and thermal discomfort issues. Maybe with UVC and some of the UV technologies, maybe, but again, doing that at a plane scale and doing that all, it's going to take a long time to do that. So to me, the most effective tool in stopping transmission in those kind of scenarios is wear a mask. Is it safe? Would you, if you're not going to wear a mask at any point in time in travel, do it once the seatbelt sign goes off. And then when they tell you we're going to, you know, descend for landing, put your mask back on. And from that point on, like that's going to buy you down a lot of risk. In the middle, depends how long the flight is. In general, I would not say it is without risk, but it is the least risky part of the journey.
What process do you recommend for folks to do a fit test at home?
Yes, so there's a couple of there's a couple options. In general, you can do the Aaron Collins, like if you have no tools accessible to you, right? One tool that I like to talk about is if you can use your hands and you put your hands out like this, usually you can use them to seal around a mask. And what I recommend to people, if they want to try just a very basic level, this will get you usually to like a fit factor of 5 and 10 pretty easily, is you put your hands over to seal the mask tightly to your face and then breathe in and out a few times. You'll feel it getting warm in the mask. And then what you can do is take your hands off and do the same thing and feel if you feel jets of cold air coming in. So I actually can feel I have a leak right here. It's blowing into my eye. And when I do this, it goes away. So it's a very simple way to get some improvement in mask fit where we're basically making no leaks and then feeling if we see a difference. Typically what I find is that for most people, they can get into a fit factor of like 10 or something like that, which would be like a 10x reduction in your exposure. But for other ways, there's other tools. The qualitative fit test is another one. This is using like Bicheck spray. I referenced fit test or fit for all, or sorry, what's their, yeah, it's fit test for all. Philip, he's been working on those. They're sometimes in and out. I can put a link in the chat. They're really great. It's a very low cost qualitative test where we basically spray a Bicheck spray or a saccharin spray, so bitter or sour or sweet. And then we see if, when you do that in a hood, if you start to taste bitter. If you're tasting bitter, that means that particles are going around the mask, coming in, and they hit your tongue, and then you can taste it. You can also buy those from companies like Moldex makes one, Honeywell has it, and they have a little nebulizer. They're about 100 to 150 bucks, so it's not necessarily like an everyday use item, but usually you can find groups. Mask blocks are starting to form where people are like donating masks, but also I'm starting to see mask blocks that are getting together fit testing equipment. So that might be an also thing. Look, see, you just Google like mask block in your city, and you might find teams of people that are working together to do that. So qualitative is pretty good, and you can typically find them for a reasonable price. They have some nice instructions, and you can typically do it kind of yourself. It's not too complicated. And the best type of mask fitting is quantitative testing. That sometimes people call port account testing. That is harder to get a hold of, but there is options for that. If you are interested in doing that, quantitative fit testing, there's a few companies. If you just Google port account rental, you can rent them for a weekend. I don't think that they're too complex for most people to do. They usually have an instruction set where you punch a hole and press some buttons and walk you through it. But you can rent them for the weekend. It costs about $200 for the rental period. Otherwise, there are services that do this. So almost required every nurse and doctor and people that have to wear a mask for their workplace have to be tested. And it's usually done through occupational hygiene. I don't know why we call it in America that, like industrial hygienist and occupational hygiene is kind of some weird statements, but these are people that specialize in that. And typically those services are a remote service. And so they do them at hospitals, but they do it. Oftentimes they will do it for private individuals. So just Google occupational hygiene fit test, and they can, and oftentimes they have a qualitative or a quantitative. I recommend if you're going to pay the money to have someone do it and you want to do it locally, do the quantitative fit testing, a port account test. You can just use the kind of industry trade name of port account, and you bring the mask to them and you can do that. And I think that when we talk about masks, like if you really want to up your game in terms of reducing infection, like on an airplane or whatever, you can bring portable air cleaners, but they don't really do much. You can bring far UVC devices, but like there's a little bit of issue with that and some eye safety stuff. But if you really want the best way to up your protection game is make sure that your mask is fitted. And I'll put a link to Phil's site in there. I don't know if they're available right at the moment. I'm going to look really quick. But
They were available for like a hot second in June, and then they sold out really quickly. I got one and I love it. But yeah, it definitely seemed like this is someone's passion project that they don't always have the time to put together.
It is 100% Phil's fashion project. I love him for doing it, but also that there's not a lot of money in it. And so $40 kit, like that's great. So just keep an eye out for that. I would love if anyone's out there and really passionate about that. I think that if you reached out to them and say, I want to do this too, I want to make one of these and make them more broadly accessible. Anyone out there is interested in doing that. I think it's super, I think he has the tools to do it. I think it just lacks the time. He wants to, he could charge $100 for this and make more money, but I think that's not where his heart is. And so if there's other people that are interested, I think this is a really great tool to really improve mask fit. I think it's a great way for people to get introduced to it. It's very simple, other than having to taste Bittrex, which is not an enjoyable experience. I will tell you that. It's very bitter, and chocolate is your friend. That's all I'll say. Chocolate is your friend to get rid of that taste. But I think that upping your fit, making sure your mask fits you, is the single most effective tool that you can do. And the other thing else, I see a lot of stuff where they're trying to do like personal air cleaners that blow at your face. Just, like all this stuff, like sure they can help, but they're not really going to hurt or anything. But if you want really good protection, a well-fitted mask is, like, in my opinion, is bomb proof. Like if you can get a fit factor of 100, I can just say personally myself, I have traveled, I was all on the road for 25 days last week. I had like 5 flights, tons of trains. I was packed in a train that was the worst train ride of my life, where I literally had to like stack my bag, and it was like 50 people and everyone was like just packed in a train for 30 minutes, right? And I made it 25 days. We have PCR tester at Open Arrows because we're a bunch of crazies. And yeah, so 25 days, and and I've still maintained my Novid lifestyle. So I think what I have is that because I have a fit tested respirator, I've done this so many times. So I can't stress enough that the tool to up your mask game, once you found a great breathable mask, once you've got one that you think fits you pretty well, is think about fit testing, and that will take you to the next level. And when you get to a fit factor of 100 or beyond, I think that pretty much as long as you can achieve that in multiple donnings, like in my opinion, my personal opinion, the way I live life is I'll do anything in that thing. I'll go to the bar, pop it down, have some drinks, whatever. Like that's the lifestyle for me. And I still manage to do it. I go to concerts, I go to movies, I just do stuff. And when well-fitting masks are so effective.
Yeah, obviously it's anecdotal, but my 3M Aura and I have been to movies and concerts as well. And for me, that's been a great way of still feeling like I can live my life while being smart. I also understand saying that's too big of a risk and I'm not going to do it. So I certainly don't take this chat as me saying you should go to concerts. That was a risk assessment that I made because I've fit tested my mask and I feel pretty comfortable in it.
Yeah.
All right, final question for you, Aaron. Is there a mask you feel is the most universally recommendable for a variety of faces and activities?
So I will say this with one caveat, and I see this happening a lot, which is I think in general, the 3M Aura is like, if I'm going to give you one mask that I think is more likely to fit, that is like usually the mask. However, I will caveat that it does not fit everyone. And there are people that I see, a lot of people like talking about bifold. Now, this is an ear loop bifold, but pretend it has head straps and it's an N95. A lot of people say, these fit nobody. These only fit like very few number of people. And while that is true, what I found happen is that people will try all the popular fitting masks. And so some people, bifolds work great. Like my father-in-law, bifolds are like the only one that fits him well. And what I find that happens is because they lack fit testing. But what I see happening is like, they'll try an Aura, they'll try these common ones like, oh, they don't fit, none of masks fit. But actually the masks that people think mostly don't fit them will work for them. And so to me, fit testing is like the most important thing. Like if I had a magic wand, it would be like a hodge or like a selection pack of all these different masks, right? Of different sizes and a fit tester. And that's what we need in the world. Now, I understand that that's complex for people to do, and there's not a lot of incentive for people to do it, but that's what you need. When we think about shoes or anything else, it's pretty rare that the shoe I like is the shoe you're going to like. I might say, this is a great shoe. It fits my foot great. I have this style of foot. And you'd say, oh, well, I have very narrow and very tall feet. So that actually didn't work for me. And so it's very much like shoes. And sure, there is a broader consensus that auras and other types of trifold masks fit better. But I think what happens is there's a segment of population that doesn't fit, and then they feel like nothing fits them because they're not going to try the bifold, because I was told the bifolds don't fit anyone. It's like, well, they don't fit a lot of people, but actually they might fit you, and that might be the mask for you. And you never tried it because everyone was like, oh, that's a crap mask. And so my vision is, look, we got to stop talking about N95s. In my opinion, we need to be less focused on ones that fit everybody, but just one, making that data more public, but also saying that masks that just because they don't fit you might fit a different segment of the population. I wish we had facial scanning technology that would correlate it. I think we have all of these tools at our disposal that could make mask fitting so much better, but there's no economic incentive for people to do that right now. There's no money in masks right now. Mask businesses, a lot of companies are going to be going out of business or have gone out of business. So there's just no money, and there's no government incentive for companies to do that. There was a lot of push 2 years ago, but now the money's kind of moved on to other things. So I think in general, what I would say is start with the aura, start with the one, like check out my top mask picks. Cause I actually think that the most breathable masks are where I'd start. Buy the sample of high breathable masks and see if you can find one in there. Cause if you can, you'll love wearing those. And then if you can't, then you have to start falling back to kind of some broader selection, but invest in fit testing tools if you can get a hold of them, Moldex or whatever, qualitative fit testers, or spend some cash to do the quantitative. And hopefully in the near term future, there will be much lower cost tools that are widely available to people, but that's still going to take us a little bit of time to finish all that work. So that would be my pitch.
Perfect. Thank you. We officially killed my AirPods, so hopefully you all can still hear me, but Aaron's smiling, so I think we can. Thank you so much for being here tonight. I wanted to turn it over to our team member, Paul. He has a quick address to give us.
Thanks for the intro. All this talk about protecting ourselves from airborne aerosols emphasizes the importance of clean air infrastructure, and now we have a chance to do something about it. I'm excited to announce that Congressman Don Beyer has reintroduced the Airborne Act of 2024. If passed, this bill would incentivize non-residential building owners through tax incentives to conduct indoor air quality assessments and upgrade their ventilation and air filtration systems. Improving indoor air quality benefits employers, workers, and children by creating a cleaner environment. The bill in its current form calls for an older ASHRAE Standard 6.2.1 to receive the tax credit, but MaskTogetherAmerica is seeking to amend the bill to include additional incentives for ASHRAE 241 or better where possible. ASHRAE 241, developed in 2023, is considered the gold standard in reducing the risk of airborne disease transmission and was designed for the control of infectious aerosols at the request of the White House. I encourage everyone to look into the differences, but we all deserve the best possible protection. The Mask Together America now has a letter campaign where you can contact members of Congress, urging them to support the bill with additional ASHRAE 241 incentives. Please be sure to customize the letter and share it for a greater impact. I also encourage you to call your members of Congress. So after years of advocating for clean indoor air, this is an excellent step in the right direction. So visit, there's the bit.ly/airborne241 to sign on today. Thanks, everyone. Breathe safe.
Thank you so much, Paul. And thank you to everyone who came tonight. We really appreciate having you here. We really appreciate building community with you. Thank you for your passion in spending time talking about airborne mitigation. This is definitely not the most exciting topic for most people, so you guys are really special for caring about this. We're working to build a great future for everyone, and hopefully we're going to have some new information that we can share with our family and friends. And we appreciate you getting involved where you can. If you want to get involved with us, email MaskTogetherAmerica@gmail.com or contact us on one of our social media platforms. We're always looking for more volunteers, and we'd love to have you. So please get involved with us if you like. Otherwise, follow us on social media, stay in touch, and we will see you next time. So thank you, everybody.
Thank you. Yeah, thanks. It was really cool.
Thank you, Dr. Haddrell. That was great talking. I really like to hear all that discussion. Thank you for staying up till at least 2 a.m. now.
Yeah, I'm learning a lot, Nate. Holy hell, you got a lot of information.